All right. Hey there, this is Bram Kanstein, and you're listening to Bitcoin for Millennials. In this episode, I'm joined by Giovanni Santostasi. He is an Italian physicist and chief scientific officer at Deepwave Technologies. I discovered Gio's Reddit post, 15 Years of Bitcoin Power Law, a few months ago, which was a follow up to a post called Bitcoin Power Law over a 10-year period, all the way to the Genesis block, which he posted 5 years before that. And I was instantly triggered because I had read about power laws before, and his username, econophysicist, was even more intriguing. So, as I just mentioned off mic, I think I searched for you for like a week because you were pretty hidden. But eventually I found you, we got in touch, and finally we got to recording because, in the past months, your model blew up. You got more attention on Bitcoin Twitter. So I thought it was time to really dive in together, into this really interesting, entertaining, but also very challenging subject. So I want to welcome you, Giovanni. And
thank you so much.
Yeah,
I like your origin story, the origin story of how we got to know each other. That is so cool.
Yeah. I really searched for you, and I found like an old startup. Then I found a young guy, but then I found you, and then I was like, is it this guy or is it the younger guy? But eventually, I think I DM'd you on Twitter, and we tried a few times to schedule. So I'm happy that you're here, and I think I'm just going to be the student. You're the teacher, as you are in real life, also. And I would love to just go through this power law model that you created, and I'll just ask questions in between, probably some dumb questions, but I think that's fine. I think I'm a general representation of my peers.
There are no dumb questions. If a question is asked, in a direct way and in a sincere way, is never dumb. In fact, some of the dumbest questions lead to discoveries, because one of the things that happened to me by since I am on X active is interacting with people like you that ask questions and make me think, and they come up with new ideas. So I made more progress in the last few months than in all the history of me working on Bitcoin, that is almost 12 years now.
Yeah, very cool. I think I think the bigger spotlight also helped you to refine it more, I think, right? I mean, on Reddit,
Correct.
These posts were pretty big already, I think, and lots of discussions. And I saw you were also very active, in the comments. But I think Twitter is just has become like a new audience for you, and a new pool of people to discuss this with. So that's very cool to see. I just actually wanted to start, if you could share a bit, about your personal journey with Bitcoin. I know you've been a Bitcoiner since 2012, and that you heard about it before, that you downloaded a wallet, but it was too complicated. When did your interest get back? and what made you get it?
Yeah, it was this article that actually spinned in my X account, because for two reasons. One, I'm very grateful to that article, because it really what convinced me finally, because like you say, I heard about Bitcoin in 2010. I downloaded the wallet. At that time you could mine. It was a little bit too complicated at the time, because everything was meant for hackers, almost like you need to be a hacker to understand this language. It was a little bit unfamiliar to me. And then I say, okay, I'm going to do it, and then I didn't. That actually is the first lesson. Never do like what Giovanni did, that is postponing something about Bitcoin. Never postpone anything about Bitcoin. If you are lucky enough to meet Bitcoin, don't postpone. Just understand it and then do. But in my case, I postpone it. Everybody else. It was not a matter of not understanding it like a concept. I loved it from the beginning, but I needed more information. So finally, I got this article in a newsletter that I was subscribed to, about futurism, about positive understanding about the future, this vision. It's kind of a philosophical movement where you like, people like AI, people like going to Mars. So this person was describing things in that way, and in particular, he was mentioning how, this futurist, it's a movement called transhumanism that I like. It's part of my identity. And he was mentioning how, we want to change the world, we want to make it a better place, we want to cure cancer, poverty, all these things. And many of us don't have the resources for it. And he say, look, there is this new thing called Bitcoin. It explained the technology. I completely understood the technology. I fell in love. I saw also the alignment with the idea of transhumanism. It's not by chance that actually a lot of the early people in Bitcoin were in that school, because, for example, Al Finney is in cryogenic state, right? In cryonic state, that is actually one of the things that some of the transhumanists think that is a good idea. If you die before you get young, maybe you can preserve yourself for the future. And Al Finney, this is what he did, right? And other people, maybe Satoshi was even part of that movement. And so, I really like this idea that it was not just about me. It was not just about me becoming rich, but if I became wealthy, maybe I could help people, and I could create an institute. I create a place where people could research cancer or other things like that. So I really thought this is the way. This is the way to do it, because I immediately envisioned this digital currency becoming something huge, and maybe even substituting the dollar, etc. I don't know. It's difficult for me for people when people say I don't get it. I didn't get it, because for me it was almost immediate. Once I read this article, and I invite people to read it because it makes a very strong argument and explains everything in a very logical fashion. Also, it's interesting because it's 2012. See how people were thinking about Bitcoin at that time. I love these early articles about Bitcoin. And in the end, it had a little chart. I had a little chart about the current data. There was almost nothing because, this was 2012. The first markets opened in 10. So we had only 2 years of data, almost nothing. And the guy was making 2 points. He was saying, first of all, it's not a bubble, not a bubble like we have local bubbles in the history, but the entire Bitcoin is not a bubble, because at that time, it was early on, people were making a lot of comparison with tulips. You're from the Netherlands, so you're familiar with the tulip story.
Yeah.
More than others, probably you studied history or whatever in your schools. But, people were saying it's going to be like the tulips. And the guy said, no, it's not, because look, we had our first big bubble. I don't remember the price. I think it went to $20 or something like that. And then it crashed to $3. And we survived. The price continued to go up. And in fact, now it's $9. Can you imagine at that time? When I heard about Bitcoin, it was $9, and it continues to go up. And bubbles don't do that. When they crash, they never recover. So it was a very interesting argument. And plus, he said, look, the general trend looks exponential. So I went, being a physicist, a mathematician, I wanted to understand it mathematically like that. So I downloaded the data myself, and I started. That is when I did my first chart. So I did my first chart about Bitcoin even before joining Bitcoin. And I needed to understand it in that way for me to make sense. And so it's almost like, 12 years that I'm making charts about Bitcoin and trying to understand it mathematically. So it's a long journey, And when I analyzed it, it didn't look really exponential, but I started to see there were a lot of regularities. So I jumped in. I decided to jump in. And when I do something like that I know it can change my life, I do it fully. So it was like a transformation for me. And Bitcoin has been an essential part of my life since. It has influenced my career choices. It has influenced even relationship. So, it's been like a companion and a master and a teacher and a field of studies and fascination for me for 12 years, So these are my interaction with Bitcoin started, and
I love
continues.
that.
And I put in, so power laws, and the power laws, that is the core of what we are going to talk about, were almost one of the first things, because once I didn't see this exponential behavior, I started to look for other type of behavior, and power laws is something that in physics is very common. And so I started to find power laws. One of the first one was in 2014 when I found a power law between price and addresses. But like you mentioned, the breakthrough was about 5 years ago when actually I saw a direct power law between price and time. That was important because it gave me an idea that now we have like a direct way of predicting the price from the time itself. And so it was a big insight. And so right now we have more than 5 years of out of sample, what is called out of sample, because some people think that I am newcomers. Oh, look, what is this guy? It's just that I didn't have, like you mentioned, the coverage or the attention, but I have been doing this for a long time, and I'm already doing prediction for a long time, so it's not a new thing for me. But if you don't mind, let's go through the slides because we
wait.
structure.
Before we go into it, I'm going to link to the post in the show notes for everyone, so they can go to I think the last post on Reddit, and then in that post there's also a link to the previous one, so they can see your proof of work. I think also see your thinking change a bit, which I think is nice. And there, as I mentioned before, like there's a lot of discussion on Reddit, which I think is interesting. People can learn about how the model evolved. I also wanted to highlight the article that's on your X profile. It's pinned, but it's called "Bitcoin: A Means for Redistribution of Wealth," which I think is an interesting title, by the way, at that time already. By Rüdiger Koch. I haven't heard about him before, but I'm gonna check that out. I think the subtitle here, it says amazing things would happen if a large percentage of transhumanists were financially independent. How can this be done? So if you go to Gio's Twitter account, you can see it on the pinned post, and there's a link to it. Before we dive in, I think you're going to talk about what is a power law, but I just wanted to start with that, perhaps, right? You shared that this power law is not just another formula, but it shows that Bitcoin is a complex system that has its own behavior that is regular and predictable. And for me, when I read that, I think I got that directly from the Reddit post. This is of course a totally different angle than how I got into Bitcoin or what I like to focus on now. Like I love the philosophical consequences and really talking about that part, right? Like what could this bring us? But when I saw this, I thought it was really interesting because the other part of my background is from startups and tech, and there you see that adoption of a technology is something that is actually pretty irregular, right? Like you could have something that's adopted and then it dies because something else comes along, right? So you have different types of adoption curves, different types of levels of adoption. You could be killed like a BlackBerry or a Nokia, right? And so eventually it is, of course, human behavior in a sense. But what caught my eye was that with Bitcoin, it's so much more complex than what's the next phone I'm going to get, right? If the iPhone comes out or the BlackBerry comes out. And so I wanted to kind of start with this. What does it mean if something has its own behavior?
Yeah, and like I say, if we go through the slides, we will have some structure, but I can answer you this question and then we can dive in. And you're right. A few things, first of all. First of all, it's not a model anymore. It's a full theory because in the last months, I was able to actually go deeper, exactly like a physicist will do with anything that you discover, because you start with observing a particular phenomena, then you go deeper and trying to understand what are the consequences, right? What is the context of this thing? If I see that the planets move in a certain regular fashion, then what makes them move like that, right? This is exactly what happened. And by the way, the planets are a power law. If you look at how the distance of the planet from and how long they take to go around the sun, it's a power law. So one could have started from there, right? See the power law, say, hey, this is what would actually kicked the scientific revolution, because people realize if there is something that behaves in a regular fashion, then it means there is some cause. There is some. At that time, we were thinking about God. But the idea was now we are understanding the minds of God, right? The universe is not made by chance. It's not random. There are some very precise laws that rule it, and so that is actually what motivated people to go deeper, to understand the cause. Newton came about. They gave the explanation. There was gravity. I'm trying to do more or less the same thing. I went deeper in this observation, and they're trying to find the causes. And now the causes give us an insight about what Bitcoin is. And as we will explain as we go through the slides, it has to do with the nature of Bitcoin itself. This is why sometimes a little bit I am a little bit provocative sometimes, because I want people to think about it and shake a little bit their thinking about stuff. But also, I'm very serious because I'm trying to give a message that Bitcoin is something unique. It's something different. The fact that we are in love with this system, it's based also. I want to show that it's based on science, that the Bitcoin behaves in a manner that is very, very different from a stock or even gold. No asset behaves in this way. It behaves really like a system, like something that is almost alive, and has all these very, very powerful relationship between all the different important quantities, right? The parameters of Bitcoin, like the hash rate, adoption, the price, all these things interact with each other, where it shows what Bitcoin wants to do. This behavior is not by chance. It's almost like the path of least resistance is what Bitcoin decided. It has this big, huge goal of becoming the monetary system of the world, and is trying to find it in the most intelligent possible way how to do this. It's almost like he knows that he has this mission of becoming the monetary system of the world, and he says, okay, how I'm going to do that? It's a huge, big task. Can I find the path of least resistance, right? Because this is also something that you find in nature when there is something happening, water coming down from a mountain, etc. It knows, in a certain sense, of course, it's because of the natural laws and how they interact with each other, but it's almost like water knows how to go down to the sea, right? It finds the best possible path given the terrain. Same thing with Bitcoin. So it's a very, very deep thing, because in the end, and you can see, I don't know if you can see the title of my slides, has to do with human value, with energy, right? That Sailor mentioned all the time how this system is all about energy, how we are putting energy into the system. Time is an essential component of Bitcoin. People that say all the time, Bitcoin is time. Well, I proved mathematically. It's almost like I'm proving scientifically and mathematically what a lot of Bitcoiners, important Bitcoiners like Sailor, even Satoshi, have said for a long time. But it's mostly metaphors, right? They use these metaphors, they use this analogy, and then I go and say, hey, actually I found the science, I found the math, I backed by data that is the on-chain data that is available to anybody who wants to explore Bitcoin like a scientific topic. It's there. It's true. We have a math to prove it. Bitcoin is time because the price goes with time to the six. Adoption goes with time in a very, very precise manner. So you were talking about adoption. I posted today a post saying the reason why Bitcoin behaves differently from any other network, because that is one of the things that we discover once we understand how Bitcoin behaves. It is a network, and has all these network properties. A network of what? It's made of human beings. It's made of machines, because there are the machines that do the mining, and it's made of interactions between different things like the market and the users and the general population. So this global network, that is a world network, has all these properties, and the interactions creates patterns, very precise patterns. Now, of course, we are not dealing with planets, we are dealing with people, so there is much more noise than you will see, but it's not completely unpredictable or random. It's actually over the long term very, very predictable. And it follows very precise laws in a sense. And we can discuss them.
Well, let's go.
There are many consequences, many philosophical consequences.
Yeah. I love that.
They are very beautiful.
I don't know if you touch upon them along the way, but if there's any that come to mind, please share also.
Absolutely. I have slides that will mention all the philosophical aspects of the theory for sure. Okay. So, I even start saying, these are the things really that drive Bitcoin: human value, how we appreciate things and how we give value to things. That in the end, it's an arbitrary thing, but also when we work together, it becomes more objective, right? And then the hash rate, it is so all these parameters that you can observe from the on-chain. Basically, Bitcoin, one of the things that we can understand about Bitcoin is this huge, big experiment. It's probably the first of its kind, where we can measure all the important parameters, like the adoption. So many people are involved in this experiment. We can measure the interactions between the agents. We can measure how much energy is put in the system. We can measure how much time is passed by. In fact, Bitcoin has its own time that is really, really cool, because everything is measured in terms of how long a block lasts. And these blocks can be are supposed to be 10 minutes, but they can be shorter or longer. So Bitcoin doesn't really know about external time. He knows about his own internal time. And the price, because price, some people dismiss it. I think everybody that is in Bitcoin is interested in price. Some people try to be, like forget about the US dollar price. But in the end, it's essential because it gives us a metric of how Bitcoin is evolving. So my approach, that is different from other people, is that I try to understand Bitcoin in a scientific manner, right? So what that means. So first of all, I have these slides that where there is this Renaissance scholar, scientist. You had a lot of them, right, in Netherlands. Same thing with Italy. You had a very active period during the birth of science. There were all these people that, in fact, I think Netherlands invented the telescope, right? One of your scientists, and then Galileo improved it and modified it. But the idea is, like the scientists started to study the universe around them and think in a different way. It feels almost the same for me, because Bitcoin has been studied, but not always as a scientific subject, right? So people have a lot of understanding, maybe some misconception, maybe some superstitions even about Bitcoin. And then science comes about and clears all these superstitions and makes us go deeper. And a lot of the things that we thought about Bitcoin, when understood by science, are actually they are more beautiful. This is one of the things that happened. People had to abandon their vision of the universe during the Middle Age, thinking that we were at the center of the universe and so on. And there are a lot of analogy, like people say humans are not determined by laws, right, or by physics, etc. And that is one of the objections that they have against my approach. And science came about and said, no, humans are not different. We are part of nature. We are not at the center of the universe. We go around a star like all the other planets do. So the same thing, we're trying to say, no, humans are predictable. No, humans can be described by science. And Bitcoin is a demonstration of that. And so we have all this information from the blockchain because everything is recorded. This incredible ledger where every single property of Bitcoin is recorded. We can download it, we can study, we can understand the relationship between these quantities. So it can become a science. Now, there are scientists that actually publish papers. There are several of them, even in important journals like Nature, for example. But there is no really a systematic approach. There is no like a center for studying Bitcoin, like if it was a science. It's something that I want to do eventually. In fact, I want to create an institute to study Bitcoin like a science. But this is my approach. I'm trying to use science. I'm trying to use data. Whenever I'm in doubt about something, and some people tell me, "Oh, Bitcoin is this, Bitcoin is that," I say, "What the on-chain data says?" Because it's a way of cutting, through the debates, and it is not anymore my opinion versus your opinion. Is what the data tell us. Is the data telling us this or no? If it doesn't, then it doesn't matter what Giovanni thinks or what Bram thinks. Is what the data says, right? Now, data can be interpreted. That is true, but at least we start from something in common, that is the data. So that is my approach, and then the next slide. It's usually my starting point, because the next slide shows how we approach these things. First of all, we try to visualize the data, because it's important to see how the data looks like, to have a feeling of how the data behaves. In this case, we are projecting the price versus time. And everything we do when we study Bitcoin, when I study Bitcoin, I'm using the birth of Bitcoin as my starting point. So you can measure it in years, you can measure it in months. Usually I use days. So the x-axis is days from the Genesis birth. So a Genesis block. Bitcoin was born on January 3, 2009. And so I'm measuring the time from that. And so when you plot it in this fashion, where you have a linear quantity that is dollars in this case on the y-axis, and you have time on the x-axis, both linear, you get this graph. And probably everybody's familiar with this, but also this is the graph that is usually shown on TV, on these financial shows, etc., mostly to actually attack Bitcoin or put down Bitcoin, because most of the time the analyst or somebody that is discussing Bitcoin will dismiss Bitcoin as something very irregular, something very erratic, right? Because yes, maybe in general it's going up, of course, okay, but look at this horrible behavior. Went to 60,000 and then it crashed it to almost like nothing, $16,000 in comparison with 60,000. Now it's going again up, but hey, I really cannot trust it. Look at this thing. It could crash all the way to zero at any moment. And Warren Buffett thinks that, right? So there are a lot of people with expertise in finance that still think that Bitcoin could go to zero, because they look at this, right? So there is not really a real pattern. You agree with it, right? It looks very noisy, very erratic. It's not something that you will dedicate your life to, like we are doing, or put your savings, your life savings in it, right? And so, but that is a problem, because Bitcoin, this is why we have a telescope, right? We need to use the right tool. We need to use the right scientific approach to understand how Bitcoin works. And when you do that, you start to reveal things. So the next slide that I show you is this one, where if you take the log of the y-axis, and I will explain in a moment what a log is. So a log is one of these tools. It's not really like a telescope, but almost like a mathematical telescope. It allows us to see things that we will not be able to see if we just use our normal understanding of data, our normal eyes. So if you take the log, then all of a sudden that very erratic graph starts to be much more organized. You can see now there is a general path. It doesn't look that crazy in terms of oscillations. There are oscillations, but they look much smaller. It's one of the things that we do because we want to reduce the noise. You can think about this oscillation, these big changes in price, almost like the noise. So if there is a general path, if there is a general behavior, remember my first article was saying there is a general path, there is an exponential path. This is what the article was claiming. Then we should see some regularity, right, in the behavior of Bitcoin. And it looks like much more regular now. Now, it's not exponential, and I will explain in a moment why. But first of all, to understand why this works, let's talk about the logs, what logs are, right? So some people studied in school, but let's do a refresher. So it's basically a function, what is called a mathematical function. And one way of thinking about function is almost like if it was a little box. You put in something in the box, and the box spits out something. So you have an input and you have an output. So the input, an easy way of understanding how this works is to think about numbers like if it were powers of 10. So that type of way of expressing numbers is called a scientific notation. So if I have 10, for example, I can write it as 10 to the 1. So it's 10 times 1, right? Then if I have 100, it's 10 times 10. So I'm multiplying 10 two times. So I'm going to write it as 10 to the 2. If I have 1,000, I multiply 10 three times, 10 times 10 times 10, and I get 10 to the 3, right? And so on. I can do 10,000, a million will be 6 times, and so on. If I have a number smaller than 1, so 1 by convention, it's 10 to the 0, and a number below 1 are negative exponents. So, for example, 1 over 10, that is 0.1, will be 10 to the minus 1. 0.01 will be 10 to the minus 2. So once you understood this, it's not very difficult, right? Once everybody, you have an explanation. When you take a number expressed in that way, let's say 10 to the 2, I put it inside the box, that is my log. What the log gives us, it's the exponent. So if I put in 10 to the 2, that is 100, the log will give me 2. If I put inside 10 to the 3, the log will give me 3, and so on. Okay? It's not difficult. So it's basically a way of getting the exponent out of these numbers. Now, it can be any number in between, right? It doesn't have to be 100 or 1,000. It can be 500, it can be 300, any number you like. But it's always going to give me the exponent if this number is expressed as the scientific notation. Now, if I have a number like 200, it will be probably 10 to the 2.3, something like that. So the log will give me 2.3, a number that is in between 2 and 3, because 10 to the 3 is thousands, right? So if I do that, then you see on my y-axis, I have 10 to the minus, I have minus 1, that is 10 to the minus 1, right? This is the exponent of that number. So it will mean a fraction of $1. Then I have 0, that is 1. I have 1, that is 10 to the 1, that is 10. 2 will be 100. 3 will be 1,000, and so on. The beauty of doing that is that now, you see how in the previous graph, when I went to the previous graph, I cannot see the action in the beginning because the prices were so small, they look like flat, right?
Yeah.
They are impossible to see in comparison with the larger numbers. But if I do it in this fashion, then everything is much more proportional. So basically, I'm giving the same weight to all these changes of 10. These changes of 10, now it becomes my focus. It's almost like I'm flying from a forest, and instead of seeing the single tree, I'm going to look at the huge big forest, and I can see the small tree, the big tree, the forest itself. These are scales, right? If I see the small tree, that is one scale. If I see like a little patch of a forest, that is another scale. When I see the entire forest, maybe I see other forests. If I go high enough, I can see a continent. And, if I see all these different things at different scale, that is what we are doing here. We are looking at all these changes of 10. These changes of 10 are called, the terminology is order of magnitude. So if I mention order of magnitude, this is what I mean, a change in 10. If I say scale, it's the same thing. It's the same idea. I'm looking at how Bitcoin behaves when I go not from, $5 to $10, but from $10 to 100, 100 to 1,000, 1,000 to 10,000. I start to see some pattern, some organization. It's much more regular if I do it in that way. And now you see these color bands that I'm going to discuss in a moment, where they are coming from the power law and the model that I'm claiming is behind this very nice regular behavior. But if you were just focusing on this graph, it will be difficult to determine we have a particular path, right? It can be done mathematically. You can come up with different approaches. You will have to try many things. You will say, hey, is this exponential? First of all, if you are trained as a scientist, you immediately know it's not an exponential. Why? Because if you have an exponential, by the way, we kind of agree that we are not going to say too much about S2F, but S2F is supposed to be exponential. It will look like a straight line. So a straight line in a graph like this, it's an exponential. And the reason is because the log is almost like the opposite of an exponential. So if you have an exponential behavior, it will cancel out the exponential and will make it look like a straight line. And you can see immediately that Bitcoin is not a straight line. So that is the first piece of information that we get from this graph. It's not a straight line because if it was, then it will be an exponential. Or if it was an exponential, it will be a straight line. It's not, it's curved. Now, it's kind of curious, right? Because here you can see from this graph that actually it goes up. It goes up almost like if you forget this oscillation, it goes up like a hockey stick, right? So
and there are a lot of illustrations that take that first graph, right, and then they show that it could go exponential. Basically, it's like
it's fantasy, right? Because you're applying some imaginary curve that it could do in the future. We need to focus on the data. Remember, on what we have in front of us right now. What we have in front of us tell us that it's not exponential. It has not been exponential for 15 years at all, and so we have to exclude that model as a good model. And we need to focus on what we have in front of us. So what is this?
Is it? Yeah. I want to say honest, but I don't know if that's the word. But is it a logical assumption that you would see that in the first 15 years? So you say like this is what we don't see in the first 15 years, but I'm thinking like that could also be normal behavior, right? Like if you say like there's a new
I will tell you why that is not likely. Okay, we don't know because of course anything can happen, right? It's not like planets after all. It's as close as planet as possible, so we are going to treat it like if it were a planet, but it's not, right? So in theory it could do anything, but based on the
I would agree. Wait, just to share my thoughts, like I would agree. So for example, you know, if you look at it from a technological discovery angle, I'd say the wheel would probably not have been have an exponential distribution, right? Because people used, I don't know, they walked or they had to make the wheels or
actually
whatever.
It turns out that technology is exponential. If you look at the growth of technology, there are graphs like that. There is this scientist, he's a transhumanist, Kurzweil. That is what he does. He has several books. In fact, I will give you the link because it's very beautiful. It's another similar approach to mine where you take sociological data like inventions, for example, and he goes all the way to the invention of fire. And he has this beautiful graph showing the different inventions, when they happen, all the different breakthroughs. And he shows it is a straight line in a graph like this. If you have the x-axis linear and you have the y-axis a log, then it looks like a straight line that is an exponential.
So for me, you show then that already could be preliminary, just something that
no, but in that case, Bitcoin is not an exponential from the beginning. It was an exponential from the beginning.
But then, for me, what you say is like looking at Bitcoin from purely a technological perspective is not the right way to look at Bitcoin.
Yeah, it's not a normal technology, and I will show you why in a moment. Okay. So this is the first conclusion. It's not an exponential. It has not been an exponential, and probably will not be an exponential. And will make my case. Okay. We'll see if there's a convincing case. Okay. And actually, it is a good thing that it's not an exponential. That is also another thing I will tell you, because technology is the only example of the technology progress of an exponential that is good. Any other exponential is a bad thing because eventually exponential die, but we will discuss that in a moment.
Okay.
So anyway, so the question is, if it is not an exponential, then what? Because this is one of the things that we do in physics all the time when we're trying to understand if there is a relationship between two things. We want to go with the linear graph first. We don't see a regular pattern. Then we do this graph and we see a straight line. Then we found something that happens often in nature, that is exponential growth. Now, I wanted also to say why it's curving down. It's curving down because it's losing ground relatively to an exponential. This is what it means here. It's kind of almost an illusion given the type of graph that we're dealing with. It's not that it's going down, it's simply losing ground relatively to the exponential, because we already showed from the previous graph that it's actually going up, and relatively fast, actually. So there is nothing to worry about this curving down. It's simply that it was a way for the graph to tell us we are not dealing with an exponential. So the next trick that we do in physics, once you don't find a straight line, because we are looking for a straight line. We like straight line. They are easy to interpret. They are easy to recognize for the human eye. So if we see a straight line, it means there is some kind of very regular relationship between two quantities. In this case, a straight line will not have been like a simple line, would have been an exponential, but it's still a very regular type of pattern to find. So the next step is to do this other trick. So we have a first telescope. The first telescope gave us some insights. Now we come with a bigger telescope, right? Or a more powerful telescope. So the next step that we do in physics is to use this weapon. That I'm now interacting with so many people, discussing, even with engineers, etc. Is not something that is done often. In particular, like finance people have no clue. They never did this graph in their life. Economists, they never do this graph in their life, at least the majority, because most of the financial data or most of economic data are not prone to this type of behavior that I'm going to describe. It is what is called a power law. There are not many power laws that they observe, at least the one they are familiar. Actually, there are. It's just that they don't pay attention or they don't understand it in this way, right? This is a tool the physicists use all the time. And so there are precise reasons, because a lot of things around us behave in this way, and they are revealed by this type of graph. So what do I do in this graph? I take the log of a y-axis and I take the log of the x-axis. This was different from the Reddit post that you saw. I showed this and people got kind of confused, because the first thing you see, so forget about the bands, forget about the blue line, it's that straight price, straighten up, right? It's still, you still see the oscillation, but now there is no doubt Bitcoin is going up, and it's going up in a straight line. It's crazy, right? When you see this graph, in fact, these guys at what Bitcoin did, actually, they had a Berger graph, right? And you're going to interview H.C. Berger, you told me, in a little while. But he started his adventure in Bitcoin by looking at my Reddit post. This is how he did it. He saw my Reddit post, when he will tell you when you interview him, and he thought I did something wrong. This is what I said in an interview. He said, this guy is stupid because he did something wrong. It cannot be that Bitcoin is a straight line like that. He made a mistake. And then he saw my name, econophysicist, and he said, maybe it's not that stupid. And then he realized what they did, that they took the log, and he's very clever. He's a very clever guy. And he started to think about this. And then he realized that this has this word. That was the only way to show Bitcoin price. That we all should do this all the time, because now there is no doubt, like showing it to your friend, to your not orange-pilled friend, that show you think that Bitcoin is going down. Look at this straight line. Look at this straight line. It's going up and up and up and up. Now, sure, there are oscillations around that straight line, but it's still going up. It's much better graph. That graph it kind of seems to flatten out, or that graph it does crazy thing. This thing doesn't leave any doubt. There is something very precise, very almost like magical, about Bitcoin behavior. What the heck is that straight line? And by the way, if I average that price over I can take a window of few months, a window of 1 year, 4 years. I already have graph like that in my X account. You can see that black line going flatter and flatter and flatter and becoming that straight line in the middle, that orange line in the middle. It becomes a straight line, a real straight line when you average it, right? The reason why we don't see a perfect straight line is because of these bubbles, that we are familiar with. Every 4 years, there are these bubbles that make the price oscillate. Now, and this is what I'm trying to reproduce there in that blue line. I'm trying to show some kind of oscillation. By the way, these oscillations are very precise. They're like sine waves. The reason that they look closer and closer is not because of the time between the blocks, between the halving becomes smaller, is because this particular graph, time becomes compressed. It's a kind of an artifact. It's a trade-off, right? When we do this transformation, they are called transformations. Like when we did the transformation with the log linear, what was called the log linear, the second graph that I show, there is some kind of trade-off that was, we are distorting the time along the y-axis. In this case, we are doing it in both directions. So we are kind of compressing the time. The time becomes, it takes longer and longer time to move along the y-axis, and so it makes look like the sine wave is also compressed, but it's an artifact. It's not true. It's 4 years. Every time the distance between these peaks is always 4 years. Now, the first bubble is actually an anomaly that I don't include usually in my model because it's different from the other one. And also, see, the stars represent the halving. It happened before the halving. So I still want to go back eventually and trying to understand why it happened and what caused it and so on, because I want to understand every aspect of Bitcoin. But usually I don't include it in my model because I'm focusing on the bubbles that happen after the halving, because they are associated with the halving. So now, what is the straight line? The straight line, it's a mathematical process, and through an algorithm. We don't do it by hand. It's a computer program that does that for us. Everything here is all done by computers, by math, by calculations, nothing by hand, right? It's you basically ask the algorithm to find a line that has a minimum distance from all the different points in your data set. So it's that line that makes happy the majority of the points. Say, okay, let me find that line that represents the minimum distance of all the data points from this line. And when you have a line, there are mathematically, if you remember from high school, there are two numbers that represents a line: the slope and the y-intercept. If you give you these two numbers, the slope and the y-intercept, you know the line. So you run this algorithm and it gives you two numbers. It gives you the slope and it gives you the y-intercept. And so once you have that, then you can write an equation that represents this behavior. Now, what is this behavior? It's not really an average behavior. It's kind of like a general trend for the price. And we can call it a fair value if you want, because you can notice that the price is above that. It depends on the cycle, and it's also not a randomly. So, this one another thing that when I explain the model, some people misquote or they're trying to dismiss it by claiming this thing. Say, well, these oscillations around this trend, maybe you found a trend, okay, but the oscillations are so big it is almost meaningless. It's nonsense. You didn't understand what this model represents, because you notice that the behavior of Bitcoin around this line is very precise. Like, for example, we have areas, these green bands. So now what these green bands represents? Well, it represents deviation from the trend, like 20%, 40% deviation, and so on. So, and you have deviations below the trend and above the trend. And you notice that the behavior of Bitcoin is not random. It's not like a bunch of dots that are all over the place. That's what a random behavior would be, right? If we had like a bunch of, it's like a fuzzy distribution of dots all over the place around this line. It will be still interesting. It will give us still a general trend of the behavior of Bitcoin, but it will be much less interesting. It's much more regular than that. You can see, for example, that there is a majority of time, there is a large amount of time for the price to be within that green band. You see that? How that behavior is. That is basically when we reach the bottom. In fact, we spend about 2 years in that area. And then we spend another year going up and reaching we leave at green area. We start to go, and it happens always at the same time in the cycle, in a very, very precise way, almost like a clock. And then it goes up and they reach a certain peak. And it takes again 1 year to do that. And then for 1 year, very precisely, it goes back to the trend, almost like the bubble didn't exist at all. The bubbles, you could look at the bottom of a green band and think that is the real behavior of a price, because the oscillations go up, they go down, and they go back all the time to that green band. So that is actually the bottom line. One of the things with the theory, because now it's a theory, and I will explain in a moment why it's a theory versus a model. Right now, it's just a model, but I will put everything together in a real theory of Bitcoin. The theory says that bottom line has to do with miners, has to do, if you go below that level, you are going to have a situation where the miners are not profitable. So there are very physical reasons that have to do with the nature of Bitcoin. This is why we go beyond this being just a model. It explains almost everything about Bitcoin. It explains why we have the bubbles, why it behaves in this way, what are the causes, everything. If you want to, unless you study this model, that is my claim. And I know it sounds a big, huge, crazy claim, made by somebody who wants to make a big deal about his work. But my claim is, if you don't understand this, you don't understand almost anything about Bitcoin. You cannot talk about Bitcoin if you don't understand this. Every Bitcoiner should study this first, and then everything else that is interesting to them about Bitcoin. Because unless you understand this, you don't understand how Bitcoin works, right? What it does, why it does it, and so on. So this bottom line has to do with miner capitulation. If we go below that, the miners became unprofitable. And so the system somehow, and we need to understand, as we go deeper and we want to understand all the aspects of Bitcoin, we need to understand that more exactly, why it happens, how the price knows what the miner cares about, if they make money or make money, how that mechanics happens. We need to study, because once you start with a theory, you need to go deeper, right? But at least we have a starting point, we have a framework. So we know that has to do with the miners. And you notice that we never go below that. In fact, if you go here in this region around 2020, July 2010, you see that deep nearby the third star. There is like a deep, sharp dip there. That one, it's COVID. So during COVID, the price, we were a little bit above that green band, because maybe we were some news. The news can affect the price locally, temporarily. So maybe we were something that made the price a little bit more, let's say, enthusiastic or bullish than it should have been. And then COVID came and it gave it almost like a reset. And so the price crashed, arrived to that green band, and bounce back. And then because the halving was close by, we started to go up, in this particular way that I explained before. And so you start to go deep in how the price relates to this general trend, and you start to learn a lot of things about Bitcoin, why Bitcoin is doing certain things, why the peaks are where they are, why they're decreasing, right? The peak seems to be decreasing over time relatively to the general trend, why that happens, and so on and so on. So you have now a tool that makes you go deeper and deeper in understanding Bitcoin that you didn't have before. So, but the first thing is that from the power law, remember we told about these two numbers, it's relatively easy to show, and I show it in my Medium articles. I show them my different classes that I have on my Discord channel, etc. But it's relatively simple to show that these two numbers, this intersection and the slope, are actually, it can be rewritten as what is called a power law. What is a power law? A power law
Wait, can I share? I want to share a short reflection, and I hope I think you will get into this, but what kind of messes with my mind here? I love this long beginning. I think is really nice just to illustrate. I think what the essence of the discovery is, right? I think what messes with my mind is that, if I look at Bitcoin from the beginning, we have the issuance, formula, and when you draw that out, it's kind of like it's inverted parabolic, right? Like it goes up and then it goes flat, like for the issuance, right? And so that's how you can kind of visualize what the issuance of the units of Bitcoin are.
Yeah.
That is basically the only mathematical visualization you can create from the concept of Bitcoin, right? And then around that, we have like how many nodes are there?
But you see, for example, the issuance, as part of a theory of what we discovered looking at the data, has zero impact on price. Absolutely zero.
Which, what did you say? What did you mention?
The issuance, how many Bitcoins are produced, have no effect, has no anything to do with price.
That's very
that is one of the things that many people see. This is why I say it's like the Copernican revolution. People thought that Earth was at the center of the universe, and they lived for centuries with that. And with Bitcoin, one of the geocentric ideas that is wrong is that issuance has anything to do with price. Zero. That's zero. It's a different topic because many people attack me. I need to make this observation. I'm not against a fixed cap, right? Because in fact, eventually I'm going to write a beautiful article showing that the fixed cap has to do with another physics principle that is called conservation. And Bitcoin basically has this property of conservation of money. That is a fantastic property because it's exactly like nature. Again, in nature, we have conservation of energy, conservation of momentum. It's all about conservation. It has a fixed cap on anything, nature, even if it is so abundant, like our nature can be so abundant and have conservation of everything. Well, Bitcoin does it in the same way, like that. The production of Bitcoin is programmatic production of Bitcoin, the issuance that you mentioned, that is one of the things that we can draw mathematically, like you explained, but I like that, has nothing to do with the price. It's not correlated with the price.
I think this is the kind of the point of my fascination that I wanted to make. Like that is the only thing we can visualize. But the price, right? You use the price in this theory, right, to show like the price is the result of a lot of different factors, right? Like how many people understand Bitcoin, how many people run a node, how many people start a miner, how many people buy it, hold it, use it, sell it, whatever, like all these things, right? So what blows my mind is that there's so many different elements that eventually culminate into that straight line, right?
I know. And I didn't make it up, right? Bram, if I don't come here and say, hey, Giovanni wants it in this way. When I saw that straight line, I fell from the chair. I thought, what the heck? I also thought that I made a mistake. I went back and I recalculated. There are many times in the job of a scientist where sometimes you get some crazy result and then you have a bug in your code. I thought I have a bug in my code. I went back and I checked and there was no bug in my code, And so when you're a scientist, then you stop once you verify that there is not a bug, that crazy straight line, it's real. Then you stop and think, what is going on? And you're trying to understand it. Whatever consequence, and you're right, that is you are one of a few people that express the wonder behind and also the skepticism behind this crazy straight line behavior. Because in one end, you will think, how is possible with all these traders, all these people, all these
so many
miners,
elements
that come together, they create such regular behavior. Something is wrong. I will imagine something much more complex or not predictable, random. No, this is what the data tell us. And as scientists and as rational people, we need to understand it. You see, that is the problem. Some people look at it, they get a little bit surprised. Some people get scared. Some people ignore it. Some people walk away. Some people think I'm going to do what I was doing before. I don't need it. I heard so many things, some irrational behavior on X. It's very interesting how people react to something like this. Now, some people get fascinated. They want to understand more. They come to my Discord group. We study. We read books. We try to go deeper. Other people ignore it. They think, I don't need it. I don't need this. I did it. I was in Bitcoin for 5 years. I have been for 10. And we want to dismiss it, but you cannot. If you do it, you don't understand Bitcoin. I'm sorry. And other people think that is some artifact. Other people think that is, it's really makes you question what is going on. And that is one of the things. Like, how is possible? But in a moment, I will show you many other crazy things that actually behave in the same way, because this is the beauty of it. If it was just Bitcoin, then we will not have a context, but there is an entire context where there are a lot of different natural phenomena, including humans, because humans are part of nature. We are nature. And there are many different things that I will show you that are as complex as Bitcoin, like a city, that behaves like these straight lines. So it's not the first case. We have a lot of examples. This is also what gives
and is it
power
necessary
to the theory, because we have many examples of human behavior that are ruled by these power laws. There are power laws all around us, including complex human phenomena like the economy of a city. I will show you in a moment. I have slides for that where even the number of gas stations. You tell me how the number of gas stations in a city follows a straight line like that. How is possible? Is there a committee that comes together and say, hey, this is the number of gas stations, it needs to follow power law, otherwise we need to close that gas station, we need to open another one. There is not such a committee.
Well, it's kind of
they come up naturally, and there is a reason why they come up naturally. Also that is part of the theory that tell us why this power law comes into place. There are very precise mechanisms that give origin to power laws, and I will explain them in a moment too. And then once you understand that, it makes sense. It starts to make sense. Everything that all your questions, all your doubts start to be explained by going deeper and spending the time. There is a beautiful book that I will mention in a moment that is called Scale by Jeffrey West, that is a scientist. He started from physical science. When he went to organisms and animals, he was rejected by the biology community because they didn't want to hear that animals behave in this way, that there are very precise laws explaining animal behavior, explaining physiology. I had the same experience when I went to neuroscience. There was a lot of resistance. They are a little bit more open, but I was finding power law there too. And people were resisting it. No, this is not possible. The brain is not that regular. Well, it is. And then the scientist, Jeffrey West, went in human behavior, and he started to apply all these tools from physics to how cities behave, how corporations behave, how nations behave. And he found these power laws over and over and over again. So it's not true that humans don't behave in this way. They do. The question is how, and how is possible, what are the consequences? Because once you discover it, you have to accept it. You cannot close your eyes and say, I don't see it, I don't see it, I don't want to see it. It's true. That is what is going on.
So is the goal,
you can ignore it, do whatever, but then you don't understand Bitcoin. That is my position, because if this is telling us so much about this phenomena, that is almost like if you had a school where everybody needed to understand math and physics and how to write and think, and Bitcoin was part of a curriculum, you will have to study this. Like you study geometry or you study math. You don't know life, you don't understand math. Maybe sure you can live, but if you don't know how to add 2 + 2, you are, you are not really a modern human. You are not part of your modern society. Same thing. You don't understand Bitcoin in a modern way, in a contemporary way. Once we made this discovery, this is an essential, fundamental discovery about Bitcoin. So if you are a Bitcoiner, you need to understand this stuff. That is my position. Then you can argue with me, but I don't see what you want to argue about. It's an essential characteristic of Bitcoin.
So before we continue, because you're going to illustrate power laws, which I think
yes,
is great. Is the point eventually of the theory to show how it works, as you just mentioned, right? Just to find more evidence. What are the different elements that culminate into the power law, which are also little power laws by themselves?
yes.
I think, as you're going to show, so it's the how, not to answer the question why. Then is that even possible?
That is a very good
is
question.
that possible?
One of the things that Galileo did, my countryman, when he kind of almost single-handedly created science, like he was one of the founder of a scientific method, was to tell people, before we talk about why, we need to understand how. There is no point for you to tell me about the nature of a universe if you don't even know, because at that time when Galileo came about, people didn't know that you take a big stone and a small stone and you drop them at the same time, they arrive at the ground at the same time. It's a fact. It's a fundamental fact about nature. But people before him, they will argue that the big stone arrived first. And then they started to, like Aristotle, for example, he will say stuff like that, completely wrong. And, people will have criticized me at the time to put down Aristotle, because that is one of the things that they do. You should focus on your model. No, if somebody's wrong and tells me that the big stone arrives first and the other one is arriving later, I need to point out this is wrong, because otherwise you don't understand what is going on. It's part of understanding what is right, also to understand what is wrong. So the two stones arrive at the same time, and Galileo showed us that. He did experiments, it explained why this happened, and so on. And then eventually, right, once you know and accept the truth and you understand how, for example, that the objects accelerate, they go faster and faster, but there's another thing that they didn't understand at the time. Once you understand all these things, then you can attempt why. But first you understand how, because if you don't understand how, you cannot do why. It's pointless. And so in science, in physics, many times when we want to understand why, we always postpone it in a sense, right? Because when Newton came about and they say, well, okay, this is why they fall in the same way, because there is acceleration and there is inertia, and the inertia works proportionally to the mass, so the bigger object has more inertia. So it gave us an explanation, and that is a why from a physical point of view. And somebody can say, well, it's not satisfactory. I want to understand why there is inertia. And it's a never-ending story where you go deeper and deeper and deeper, and this is how we come closer and closer to why, right? So the same thing will happen with Bitcoin, because I can tell you, that you will see my theory, why it's a power law, because it's made of two other power laws. And you say, okay, wait a second. You are telling me that the power law in time is made of two power law. Okay, sure, it's a little bit more interesting. But now, why there are these two power laws? And then we can go deeper and say, well, okay, this is why there is this other power law. And then you say, well, that is not satisfying. It's a never-ending story. We go deeper and deeper, and we add more and more layers to these things. And that is how you understand things. I don't know if we will ever go down to the bottom of these turtles, right? There are turtles on top of turtles and turtles. Like this is how the ancient explained the universe. Say, the Earth sits on top of a turtle. Okay. And the turtle sits on what? On top of what? Another turtle. And the turtle, another
fractals
turtle.
And fractals and fractals.
But it's, if it was true, as we go down the turtles, we're hopefully, maybe we arrive to the last turtle. And then, we understand everything. But it's progress, right? Because now you go deeper, you understand more things, there are more consequences. You can make predictions, because it's part of doing science to make predictions and all kinds of things like that. So it's a very good question, but this is how we approach this in a scientific way, where we go a layer at a time. But first we understand how, how is fundamental. So and this is what Bitcoin is. If you have a straight line in a graph like that, a log-log graph, it means you're dealing with a power law. And you can show mathematically, remember these two things that I told you about, that straight line, they come up in this equation. So you can rewrite that equation. You can show that you can go from the straight line. I don't go in the details of this, but in my X, etc., I explain. I have videos on my YouTube where I explain this in details. You can go from the straight line to this equation. This equation is what a power law is, and this is why also is called a power law. It's a relationship between two quantity, y, in this case for us is the price, and x, in this case is the time. But it can be anything. There are so many different power laws around us that these two quantity can be anything, two things that we study. If they are related to each other by a power, and this includes even the simplest possible relationship, that is a straight line, just a straight line in a linear graph. If you have, that is the simpler relationship between two things. They are proportional, right? You double one quantity, the other quantity doubles. You triple it, the other quantity triple. In that case, the power will be 1. So it includes even that case, but it generalizes to any other case where that n is not 1. So if it is 1, it's a linear relationship, a straight linear relationship. If it is 2, for example, it's a parabola now, right? I double x, y becomes 4 times. I triple x, y becomes 9 times, and so on, right? So a type of relationship like that where you have x to the power of something, and that n can be 2, 2.1, 1.3. It can be less than 1, 0.5. It can be even negative. If it is negative, you're going to see going down instead of going up, and so on. Any type of relationship like that is one of the simplest possible relationships that you can imagine. And these are the other thing that disturbs a little bit people. How come that Bitcoin can be explained by a simple little formula like that, right? That is the beauty of nature. Nature likes simple things, not just in Bitcoin, in so many different things around us. This is why these power laws are everywhere. In a moment, I will show you everywhere. So Bitcoin behaves in that way. When you understand the general trend, it's a power law. In fact, it turns out when you do that regression things that I told you about, it gives us the slope. The slope turns out to be this power. So once you measure that slope, it gives you the power. The power is 5.83. So a number very close to 6. And then the y-intercept is this factor that basically relates the price to the number of days from the Genesis birth. That is a Genesis block. That is a very small number. The reason why it's small is because basically what this formula means is you give me a day, and I have, by the way, I will give you the link. I have a long line app that I already set up and saved so people can actually go and play with it. I have the formula set up there, and so people can experiment with it. You put there the number of days from when Bitcoin was created, and it gives you a price. So if you go 0, for example, it will give you 0 times 6, basically, that is 0, multiplied a very small number, 10 to the minus 17 means 0.1601, and you get 0. So basically the formula says that when Bitcoin was created, the price was 0. Okay, we are into something. It kind of makes sense, right? Then after 1 day, you put 1 day there, 1. 1 to the 6 means 1 times 1 times 1, that is 1. Time that very small number. This is why it's such a small number, because after 1 day, it was not 0. It was 100 million billion of a dollar. It was basically 0, almost 0, but not quite 0. So this is why that number, it's small, but not 0. Now, it took about, and we have a video. So by the way, I invite everybody to go to my YouTube video where my son did this very beautiful live production videos with all kind of animations, etc. We explain this. We use the analogy of a weight. We say, imagine 1 kilo is $1, and you can tell how big Bitcoin was at different time in history. For example, it took about a few hours for Bitcoin to have a weight of an atom. In this analogy of 1 kilo equal $1. It took about a few days to be the weight of a mosquito, I think like a couple of weeks. And then it took about 890 days to become $1. And you can put the 890 days there, and you will see this formula gives you $1. Now you go to the real chart, and you look at when Bitcoin really became $1, and you compare it. it became $1 in February 2011. That is about 900 days. So we are off by a couple of weeks, something like that. This very simple formula tells you roughly when the price of Bitcoin was at different times, when it was $10, $100, $1,000, and we are off by sometime few days. These are how
or
amazing
should have been then, right? Or should have been.
Basically, what happens is the price can be below or above, right? And if it is below, it's undervalued. If it is above, it's overvalued. And you can see it's not a random thing. I explained before from the graph, right? It depends where you are in the cycle. If you are here in the green band, we are usually about 60% away from the trend. If it is like the top of a bubble, it can be really far away because the first bubble was almost 10 times, the second bubble was 5 times, and so on. So you have to understand it in this context. But in general, the price, it's really given by this question if you are thinking that the fair value is that general trend. And sometimes it's uncanny, like for example, right now, because we are very, very close to the trend in this particular moment, if you put the number of days, it is 5,580 days or something like that. This is what it is today. And you can actually do it on Google. You can say how many days from January 9, right? And you can then put it in this formula. Right now, that formula will give you something like $65,000. That is what Bitcoin is more or less right now, and it's crazy because it's such a simple formula. The beauty of a model is supposed to be the simplest possible thing that comes as close as possible to the complex phenomena that you are describing, right? So this is the power of a model. Now, remember this number 6, because I will have a punchline in a moment to explain you why that number is so important, okay? So what this slide shows now that Bitcoin, once you understand is a power law, we are in a completely different land. It's not just another model. It's not just another equation. It's not like a straight line, like some people. It is a straight line, but it's so much more than a straight line. These straight lines are so precious. Like if you are a scientist and you find a straight line in a log-log graph, you have a paper. And if it is a straight line that nobody ever saw before, they maybe even call it after you, like this guy that discovered this straight line in this graph, and is called now the Kleber's law. Maybe this should be called the Santostasi law. I don't know, but just putting somebody maybe should start to call it like that, because, I mean, it's incredible. It's like you can really have stuff named after you because it's a big discovery. If a law really it's maintained, it tells us that there is something profound about the behavior of that system. In fact, for example, in this example that I'm showing here on the left, we are talking about what is called the Kleber's law. So this scientist, I think this happened in the 30s, something like that. He started to study animals. So he looked at the mass of an animal, and then he looked how much energy the animal consumes. And when you do that, and you do this log-log graph, and why we are dealing with a log-log graph, because notice how the emphasis is on these tens, right? 0.1, 1, 10, 100, and this is both on the x-axis and the y-axis. So we are dealing with a power law, and we are dealing with a log-log graph. So again, if you see a straight line in a log-log graph, it's a power law. Now you measure that slope, that is almost like the DNA of that phenomena. That slope will tell you something profound about the mechanism behind this power law. And he found out, so first of all, look how amazing this graph is, right? There are all kinds of animals, all the way from the mouse to the elephant, and very huge, big differences in size, thousands of times. The elephant is 10,000 times larger than a mouse in terms of mass. And the energy that they consume, all the way from a fraction of a watt, we are using this unit of energy per second, right? That is basically the power that the animal consume, the energy that the animal consume per second. Notice humans are 100 watts. That is kind of crazy, right? We are like a bulb. It's the same energy of a bulb. This is what humans consume. That is maybe not many people ever thought about that. And the elephant consumes 10 times more energy than a human. It's like 10 bulbs. It is still amazing, right? How is possible that the energy of an elephant is 10 bulbs? It's crazy.
Yeah.
And the mouse it's one thousandth of that. It's very, very little energy. The mouse consumes very, very little energy in comparison with a human. 1,000th the energy of a human. But all of them follow. Now you see, if you compare it with the planets, that is also a power law, like we mentioned in the beginning, the power law of the planets is almost perfect. Like these dots, if you put these dots on that graph, they are almost perfectly on that straight line, almost no deviation at all. Now you go to animals, you see a little bit more deviation because now physiology is more complex, but it's not random. Like this is why biologists resisted this thing, because you will think animals do all kind of different things. How's possible this animal, this lifestyle is eating this stuff, is behaving like, it's incredible.
Exactly, that's what I meant with the why and the what, or the why and the how, right?
So what is going on there? First of all, you start with how it does this, and then from the how we try to understand what, and so the what comes from the slope, because the slope is the key to understand what. Or why, so the slope turns out to be 3/4. And there is a lot of depth in that 3/4. So the first depth is that is not one. So what it tells us, as you double the size of an animal, you don't need 2 times the energy. You need 2. So if you're doubling, you go with 2, then you take the power of 3/4, and that gives you 1.7. So you have a discount of about 30% as you double an animal. So the animal, as it becomes bigger, it saves energy in comparison with what he will have to use if he was doubling the energy consumption as he doubles his size. What is going on? Why that happens? Because the first thing that if you went to anybody, say, if I double the size of an animal, how much energy the animal consumes? 2 times more. That is what a normal person will say. No, nature doesn't behave like a normal person says. He behaves in his own way, and it has his own wisdom to do that. And so as you go up and up and up, actually that advantage becomes bigger and bigger, because by the time you go to an elephant, if you compare the energy, the size of an elephant, that is almost 100,000 times bigger than a mouse, it should use 100,000 times more energy. And in fact, if you see, the elephant use 1,000 watts, the mouse 0.1 roughly, right? That is only 10,000 times. So the elephant is 100,000 times bigger, but it uses only 10,000 times. So it's almost like a saving of 10 times the energy. So the elephant will have to use 10 times more energy if this relationship was not there. So that is the first thing that we learn. Say, oh, wow, this is very interesting. Somehow nature organized itself. Now, scientists went deeper and started to understand why that 3/4, where that comes from. It has to do, just to make the story short, because it took many, many years of investigation and studies and physics and simulations and all kinds of things like that. It has to do with the fact that the body is a network. So we have all this interaction between the cells. Energy needs to be transferred to the cells in the form of sugars and all kinds of stuff like that. And the way the body does it, it tries to do it in the most saving energy possible way. So basically, there is a relationship between the volume of a vessel, when you have blood flowing to a different part of the different tissues, and the cross section of that, right? So, and he also, why, for example, it should be 2/3 if it was only area over volume. Volume goes with the cube, area goes with the square. So if it was only this thing that I described, the section of a vessel versus the volume of a vessel, it will go 2/3. But you know what? It's 3/4. Why? Fractals. There are some fractal properties that you mentioned, the fact that there are vessels of vessels of vessels, that there is this self similarity in the body, because the vessels split out in other vessels, and then other vessels, almost like the branches of a tree. So if you go inside the body, there are all these fractal properties of the circulatory system that gives you an even better advantage. It's 3/4 instead of 2/3. So it's really interesting, really fascinating, and you discover a lot of things about the phenomena by studying these power laws. This is usually the beginning. It's not the end. You go deeper and deeper and deeper. And then they are all over us. There are languages. They say, how is possible? How is possible that they show up? What about in languages where the frequency of words of a particular word, how many times a word happens in a language, follows a power law? How is possible? Did people come out together and say, hey, let's do this? No, it came out naturally. There are processes underneath that makes this thing happen. You look at the city, all the different properties. This is more symbolic, but here it's very similar to this. They organize the number of cities, how big they are in terms of how many of there are in different countries, Japan, China, all different countries. They are different in their economies. They are different in their lifestyles, in the geography, the climate. Power laws everywhere. And to a point where the scientist, this Jeffrey West is one of the leaders, but there are many like that. They found out that the number of gas stations in a city goes with the power law, the number of libraries, the number of crimes, the number of terrorist attacks. You will think terrorist attack. What the heck? The terrorists come together and say, hey guys, we don't have enough this year. We need to follow the power law. Let's make a little bit more terrorist attacks so we can be on the power law, because so Giovanni can make a point in his presentation. Do you think that is what is going on? No, it organized nature, included human that are part of nature, organize themselves through these power laws, and there are reasons. So one of the reasons, and here I show many physics laws, like almost all the physics laws are power laws. I will not say all of them, but a lot of them. These are like different phenomena: electromagnetic force, heat capacity, inertia. There are all power laws with different exponents. These are the exponents, that little power that we mentioned, and is almost like the DNA, the different type of laws, according to whatever exponents we have, they tell us something about the nature of that phenomena. So that number, the little number, is essential. Remember, for Bitcoin is 6, and so there is this beautiful book called Scale. I say, everybody, this should be the new Bitcoin standard. If you really want to understand Bitcoin, read the Bitcoin standard and then read this book, Scale. It's an essential book because it tells us, it basically explains the things that are mentioning, how these power laws are everywhere in nature. They are all around us. There are physical phenomena, there are biology phenomena, but even human phenomena that are ruled by this power law. Because Bitcoin is a power law, you probably want to understand why they are so important all around us, why they come up, what are the consequences, and so on. And the title is Scale, because scale, remember, is this change of time. So that is one of the essential properties of Bitcoin. That is this system where scale is important. I'm writing an article, a scientific article, because I want to publish this theory in a scientific journal. And it's a theory now, because it's not anymore. So my quest went, I need to understand that 6. I couldn't sleep at night sometimes, because understanding that 6, it's, remember, because I just mentioned how all these different laws, their DNA, their nature, it's explained by that little number. That little number is the key to understand what is going on in that particular power law. So I knew that I needed to understand that 6. So I started to think. I will go under the shower and think about the 6. I will walk and think about the 6. And then actually through the interaction with the X people, because it helped a lot to talk to them, sharing my knowledge, or people asking me questions. One day I went to sleep with all these ideas, and it came to my mind. The entire solution came to my mind. So I went back and looked at the data, and I started to plot everything as if it was a power law in a log graph. And hold and behold, what I found out, well, that adoption, that is basically addresses in time. So I'm using addresses as a proxy for adoption. People resist that and they are objection, but we don't want to go in the detail right now. But if you go in my X account, if you go in my Medium, I explain why.
I would say the price is the proxy for adoption, but yeah, I understand what you're doing.
Addresses are also a measure of network activity, right? So how active is the network, and that is a power law. It's a beautiful power law, and it's a power law of 3. So addresses go up in time. Look at this beautiful straight line. So this graph here shows addresses. It's almost a perfect, even better looking, even more straight line than the addresses. Look at that. How is possible that the addresses follow this incredible power law? you know. And the other thing to notice is the order of magnitude. How we go with price, we go from a fraction of a dollar all the way to almost $100,000. That is many orders of magnitude. It's the equivalent of going from a mouse to an elephant. In fact, we have a video about that. In fact, my son say, well, it's more like, and he came up with a dinosaur, some huge big dinosaur. It's not even an elephant. It's like some crazy dinosaurs, right? And when Bitcoin will be a million, will be the equivalent of Godzilla. Will be 10 blue whales, right? When Bitcoin is a million. By the way, another thing about these models is that now you can extrapolate them in time because you have an equation and you can say, hey, how long it will take for Bitcoin, given this equation, this power law of time 6, to reach a million. And it turns out 10 years. It will be 10 years from now when Bitcoin. You can say, in fact, one way of thinking is doubling the time that with Bitcoin has existed. So it's 15 years. So if you go in the future for 15 years, then it's double the time. And we know already what to do. You take 2, you take the power of 6 of 2, that is 64. So right now we are around $60,000, right? You multiply that by 64, you get close to $4 million. So it will take 15 years to reach $4 million. It's amazing. It's very, very precise. Now, is it going to be exactly 15 or 14.9, 15.1? Of course, right? There is some uncertainty there because we are dealing with human things. We are not, as we go from planets to physiology to humans, there is more and more noise. But it's not random. It's precise in this way, right? With a certain given, imprecision due to the noise. But the power law of addresses that represents adoption goes up with the time cube. It's not an S-curve. That is another thing that people say. Oh, adoption is an S-curve. It's not. It's a power law. And there are very precise reasons because, like you said, we want to understand why and what, and we go deeper, and there is an explanation for that. Now, it turns out that you want to ask the other question, say, well, given that addresses grow up in this way in time, what is their impact on price? What is the relationship between prices and addresses? It turns out to be the square. And that actually is very interesting because it's a famous relationship that this engineer came out with. He wanted to explain the value because he actually was selling, he's the inventor of the Ethernet. His name is Metcalf, and he was trying to sell. I heard the lecture I actually posted a couple of days ago on my X account. He wanted to sell more of these units that basically was like a little card that you put on your computer because at that time computers needed an additional extra piece to connect to the first type of internet, and you had to buy it for $1,000. So he wanted to sell a lot of them, and he was explaining people that actually more connections there are, higher value there is in their network of computers. And he came out, he showed mathematically that it turns out that the value goes up with the square of the units that are connected. So if you have many computers and you double the number of computers, the value of your network goes up with 4. If you triple it, it goes with 9. Bitcoin behaves in the same way. So let me finish because we have a punchline, the first big punchline. Do you remember the 6 that I told you about, right? Now we have an explanation for the 6 because, and this is how we know that we are in something big because this is why it's a theory. We are going deeper inside how Bitcoin works. It's a network. First of all, it tells us that it's a network. And there are 2 fundamental properties of a network, how the information spreads in the network with the cube of time. And then the network value itself with the Metcalf law. And it turns out it's basically a simple equation that, and the equation says price equal Bitcoin square. So more Bitcoiners we have, we double the number of Bitcoin, we get 4 times the price, 3 times Bitcoiners, we get 9. So it goes up with the square. Now the Bitcoiners grow up with the cube. So you take cube to the square, you get 6. And this is why we see this beautiful power law of 6. It comes from the combination of these 2. Now it turns out, if you go around this circle, see this, I took it from the Bitcoin standard, this beautiful virtuous circle where there is demand of store of value, that makes go the price up. So for every step of this circle, I have a power law to be associated with it. So basically we go around this circle, and for every step there is a power law. So the power law that explains how the store of adoption goes up, the demand for a store of value, how the price grows up with the time over 6. So Bitcoin is time, and then the change in price makes miners want to join the network. Miners becomes more profitable. Yes, because price goes up in this way. And guess what? Price and hash rate are related by a power law with the power of 1/2. That is also power law. Then there is the difficulty adjustment. That is also a key to understand why we have power laws. And it's kind of a feedback loop that adjusts the difficulty as there are more and more miners coming in, and it keeps it stable. And then that creates a power law in time for the hash rate. So the hash rate is also predictable. It goes up with the power of 12. So you have 3 for addresses, price goes with 6, and hash rates goes with 12. You think this is due by chance? No. It's the beautiful mathematical Bitcoin. 3, 6, 12. And then there is a relationship between the hash rate and the addresses, because they interact with each other. And you have a loop that is closed, because more hash rate gives more security to the system. And that indirectly, even if you don't buy Bitcoin thinking, oh, there is more security, there is more hash rate, indirectly you do, because if it was not a secure system, you will not invest in particular large banks, etc. They do consider things like this, even if not directly, at least unconsciously, all this comes into place. I didn't invent this circle. I just showing that mathematically it's true. There is evidence from the blockchain, and all these steps are supported by this beautiful power law. So Bitcoin is not one power law, it's 6 power laws. In fact, actually, as you go deeper, it turns out the holding time is also power law. And these guys, if you look at the different addresses, because you can select different addresses, you can select whale addresses, you can select so addresses with values above a certain value. You can select shrimp addresses. It turns out that all of them are power laws, and all of them behave in the same way, where in the end they always give you 6. They all combine together. So they are power laws of power laws. So we have power laws everywhere in Bitcoin. So if you really don't understand this thing about power laws, you don't understand anything. I know some people will get mad at me, but you need to understand power law to understand Bitcoin, because otherwise your understanding of Bitcoin is like thinking that horses are unicorns. You're coming up with something and you don't understand the true nature of horses. You need to understand what they are. They are mammals and other things like that, if you really want to understand horses. So it's as fundamental as this. And these are all the power laws. You can see them better here. You see, look, straight lines everywhere. Log graphs, straight lines, all of them. And the Metcalfe law, etc., show that the adoption is a power law. Why? So that I will stop here, and then you can ask me some question, etc. But that is a very important thing. So why is not an S curve or an exponential? Because that bothers me. Again, right? I stop there and say, what the heck? Why? Because I was expecting an S curve. Well, it turns out that many phenomena that have to do with the spread of some information, and viruses, for example, is that, because this is what happens when you spread a virus. You spread physically the virus, but it's basically the information about the virus. Virus is like a little chunk of DNA, basically, and this kind of information. So you're giving it to another person. It's very similar to when you create a meme. This is why the meme was invented with the same idea, that is almost like a mind virus, right? So memes also spread in that, almost like a virus kind of things. It turns out that usually viruses spread like in exponential fashion. And sometimes actually they look like an S-curve, because once you reach the entire population and infect everybody, there is saturation. So it grows very, very fast, like an exponential, and then it flattens out. So it looks like an S-curve. It turns out if there is some kind of curbing mechanism, like for example, AIDS is such a case where people know that having contact with other people sexually can spread the disease. So their behavior changes. They are more reflective. They think more. They use precautions, etc. So when you have something like that, and I was amazed when I found out that. I was like laughing because they say, okay, you see, I am on the right path. This is how you know, as a scientist, that you are into something, that you are going in the right direction. Science give you these signals that you are doing something right. So I found all these papers that show that when that happens, guess what? Look at this title: Risk Behavior Based Model of Cubic Growth, exactly like Bitcoin. Bitcoin grows with the cube of time, the adoption, and AIDS was a cubic growth. Here again, you see the formula here. You see power laws here. Look at this. Power law with the power of 3 of Bitcoin, of AIDS spreading around. And there are hundreds of papers like that where they show that under certain circumstances, what is supposed to be like an S-curve becomes a power law. And it has to do with networks. It has to do with situations. There are many different cases. Like, for example, if you have a network where the connections between the networks are not similar. Like, for example, you are a super spreader, right? Because you're orange peeling a lot of people that listen to you. You are causing the power law. That is one of the things that happens. That when you have super spreaders, that is another condition under which you go from having an exponential growth, you go to a power law growth. So think about what happens with Bitcoin. People need to think about becoming a Bitcoiner. They need to reflect. They need to study. It doesn't happen overnight. It's a process. When you have something like that, you have power law growth. It's now incredible.
So the definition of Bitcoin is a mind virus is fairly accurate then.
Correct. You see, all the things that people say about Bitcoin without any evidence, I'm finding the evidence. That is my role. I'd say, yeah, you're right.
I love
certain things are wrong. There are a lot of misconceptions, but a lot of intuition, because this is one of it, I think, what happened with Bitcoin. As you deal with Bitcoin, you build this intuition, you build this understanding that is intuitive. But the role of a scientist is to go back and say, yeah, you are right, or you are wrong. This is why sometimes, and people criticize
you're validating more like the natural occurring thought of the people that participate.
And other things are misconceptions, because they have, like, for example, the role, one of the things that I'm emphasizing over and over again, not because I have a mania, not because it's based on politics. I don't care. I care about the data. When people say scarcity doesn't play a role in Bitcoin, because I look at the data and there is zero evidence that scarcity has any role. Now, again, this is different from claiming that the quality of Bitcoin to be a fixed cap is a fundamental quality. I will never mess with that. That is very important. And that maybe indirectly affects adoption, right? When you, one of the reasons why people adopt the Bitcoin is because they think it's a fixed cap, my investment will not be diluted. But that is a different thing. I'm saying any on-chain data that has to do with scarcity, like, for example, supply or issuance, etc., has zero connection with the price. It doesn't affect price. That is what the data shows. So, with
So you did try to model that.
Yeah, of course. I want anything that makes me understand Bitcoin deeper. I want to know. It doesn't matter if somebody show me that I am wrong with something and it makes me understand Bitcoin better. As a scientist, I have to embrace that. I'm happy. I saw that happen so many times in science conference, when a scientist presents something and then another scientist shows something different. And the guy is right. Sometimes we have a debate because, maybe we need more data, maybe we need to show it in a different way. But then when it's shown and there is no doubt, the other scientist agrees, and he actually shakes the hands of the other scientist, say, okay, thank you so much. Because, the other scientists contributed anyway, because you need to have this discussion before you arrive to the truth. And so even when you are wrong, you're still contributing, and so my role, even somebody show me that I am wrong with something, I'm still happy because I went ahead and started to discover Bitcoin, trying to understanding other people came in, they brought more information. But, if it is the other way around, where I see something wrong and they say, look, don't say that issuance has any role, like in the S2F model. It doesn't. It absolutely doesn't. There is no evidence that issuance has an effect on price. A reduction in issuance, doesn't affect price. It's not true. And we can, we another day, if you want to call me again, we can go through that exclusively. But that is the bottom line. And so, as I was telling you before, right? So this is another wonderful slide. It shows different amounts of value in the addresses, like above, if there is an address with $1, 1 Bitcoin, 2 Bitcoin, 0.1 Bitcoin, whales and dolphins, etc. The interesting thing that they grow at different rates. So, for example, big, large addresses like ETFs or things like that, they go very slowly. They don't go with the cube. They go slower. And then, but their effect, their impact on the price is bigger. So it makes sense, complete sense. They go slow, but they impact the price very big. Turns out that when you combine these two things, the growth and the impact on the price, they all end up with the power of 6 in time. So it doesn't matter if you are an ETF, it doesn't matter if you are a small little guy, your impact on the price is going to be the same. You see all these red line, and all the exponents. I take all the exponents. This shows the growth, and this shows the impact. You multiply them together, they give you the same number. Again, how this can be by chance? It's impossible. It's due to something deep about how Bitcoin works.
Yeah, I think so. I don't want to wrap up yet because I have a lot of questions. I have a lot of questions, but I think it would be fun.
And maybe I can make a final point, and then we can have questions. The final point is exactly what I was telling you, that now we have a beautiful theory about Bitcoin that tell us a lot of things. It's actually a starting point. It's not the end. It's where we start. Now we have a framework that Bitcoin is this network that has all these very deep properties, that is not random, that it behaves in a very precise fashion, but through the mathematics we can start to understand the nature of Bitcoin. And basically all these things that people repeat all the time about the nature of Bitcoin, like Saylor mentioning that is a city. Well, cities behave like power laws. In fact, you remember that Jeffrey West that I mentioned, he was talking about, he has this sentence, he says, corporations die and cities are eternal. Because guess what? Corporations behave like exponentials. And usually, with one exception, that is technological progress, exponential are bad, because what happens, and many people would like Bitcoin to be an exponential, but it's a bad thing. You are wishing something maybe very selfish because you want to be millionaire in a short amount of time, because this is what exponential do, right? With God candle and all kind of stuff like that. But then you wish for Bitcoin to die, because this is what happened with corporations, for example. They go exponentially, and then they die, because this is what an exponential does. It basically consumes everything around it until they die. This is what happened with the bacteria in a vial, right? It multiplies until it reaches 50%. Then it multiplies one more time because it doubles, right? This is what exponential do. And then they die because there is no food anymore. This is what happened with companies. This is why companies last about 100 years. There are not many companies that are older than 100 years, almost none. But cities that follow power law, because it's a more sustainable, more scaled up property of growth, they are eternal. Think about Rome, for example, or Amsterdam, right? They have existed for hundreds of, not thousands of years. And see, there is one property that I didn't mention. By the way, I have these other symbols of a Ouroboros. It is like an ancient symbol about eternity. Bitcoin is like a Ouroboros. I like also to do philosophy and mysticism. And, you go from the science to all
like the snake eating its tail, right? That one.
Snake eating its tail, right? This loop that we described before, all these power laws. This is a graph showing the bottom line that I described before, that now we understand where it comes from. It's from the miner, from the hash rate, having this very precise behavior. Is never broken because it's like a hard bottom that has to do with physical causes. It's not there by chance. Notice how these changes in the price due to the bubbles are basically like deviations and like perturbation of a system, almost like when you're running and your heartbeat is going too fast, then you want to go back to the same place. So it's crazy, right? Look at these, like it goes up, it reaches there,
this
then
one
it comes
is crazy.
back.
I love this
But
one.
it goes back to that power law, to that line, almost like he knew that he needs to go back home, It's like how this can be due by chance. No, there is real physical reasons behind this. We are into something big. Again, if you don't understand this, you don't understand Bitcoin. And the most important property of these systems is the scale invariance. And really, I will stop here. The scale invariance that I mention all the time is this thing where basically you can imagine almost like a triangle beneath that power law, right? This is the power law, this straight line. And now remember what is a straight line of. It's a straight line of scales. Scale. This is why that book is called Scale. Scale is where we put our emphasis. The scale is this change in size of time. So 100. So as the price changes by a factor of 10, time needs to change equivalently. So if we have a change in price of 10, we need to have a change in time of 10. If it is a change in 100, we need a change in time of 100. So this change, that is regular, and this is why we see a straight line, because it's a straight line, so a proportional. Straight line means proportional, right? But proportional what? Proportions of scales. And so this is why it's called scale invariant. Invariant means not changing, same, proportional. So scale proportional, if you like a more simple words. And one example to illustrate that is a triangle. So if you go here, let's say until 2019, let's say, and I make a triangle, then I can say, you know what? Let me extend this triangle. Let's make it proportional. And then I can predict the price in that way, because this idea of changing in proportion, it's the essence of what a scale invariant process is. And these scale invariant are like that, and they are invariant because they continue to do that. The idea is whatever is making this thing happen doesn't change. It's the same process at all the scales. And that is actually the best way. If you add today, I've made a post and say, if you have a system that needs to go from being adopted by few people, right? When Bitcoin was invented, just few friends of Satoshi, and it was worth nothing, literally nothing, all the way to be something that billions of people use and is worth tens of trillions of dollars. And you need to grow through all these scales. How will you do it without collapsing, without destroying, without having some kind of crisis or killing itself? You will do it in this way. You will do it in a scale invariant way where it doesn't matter where you are in the growth. You're going to do it in the same way that you did it before because it was successful, right? You did it successfully going from 0.1 to $1. You did it successfully going from 1 to 10. You will continue to do the same thing. The same processes that are behind the growth of Bitcoin will continue to work. It's just we are going to scale up. So in the beginning it was just few friends, then it was a little bit more through the interaction of the networks. And now there are the ETFs because it's the right time, at the right place for something big like the ETFs. The ETFs don't represent a change. It doesn't represent a revolution. It represents just exactly what we need to go the next step. I even calculated mathematically to go to the 1 million. You see, this now we can extrapolate and we can go all the way, that this thing goes all the way to 10 million. But if you go to 1 million, that is there, that is basically just another order of magnitude. It's nothing special, because we are almost 100,000. It's another order of magnitude, a factor of 10. So you think that Bitcoin did it in 8 order of magnitude from being a little mouse all the way to a dinosaur, and now it goes to Godzilla, that is another factor of 10, is going to do something different? Absolutely not. And, it will go against its nature. Its nature is to be scale invariant. See, the science behind it is one of the few times where in science we can make prediction. When you have something scale invariant, we do it all the time. There are many systems like this, like the growth, for example, it turns out the growth of tooth, horns, thorns, many different shells. They are all power laws and they are scale invariant. So you can look at the elephant growth of a tooth after 5 years and say, how long how big it will be when the elephant is 50. And I have even the graph here. It's scale invariant. It's a power law. You can make a triangle where the pink is the female, the blue is the male, and you can proportionally, you go to 5 years, what is the rate of growth, and you can extend it and say what the growth will be. See, it's a little bit of noise because it's physiology. There is some uncertainty there. It's like our little bubbles, but the general trend is there. It's the same thing with Bitcoin. It's scale invariant. Once you understand that, every Bitcoin should be familiar with that term, scale invariant. Google it, study, read that book Scale, because that is the core of understanding these processes. And Bitcoin is a scale invariant process. And this is why it's predictable. It's one of the few things in science that actually is predictable. There are two things in science that are predictable: things that are scale invariant and things that are periodic. And Bitcoin is both, because we don't have time to go too deep in the cycles, but that is also the other component, that Bitcoin is very cyclic. And it has both. It has the cyclic nature that is very predictable, like the orbits of planets, or the seasons, and it has scale invariance. So it's one of the most predictable assets or social phenomena, whatever you want, in existence. So this is why people will say, oh, you're basing your understanding on the past. Yeah, exactly, because this is how scale invariant works. Scale invariant means you give me any time in the evolution of Bitcoin, it did the same thing. So it will continue to do the same thing. You don't understand scale invariance. You need to update your understanding, because I say some people have good intuition, and we are showing they are right, and other people still use geocentric ideas about what an asset is that is unpredictable, etc. Well, because it's not Bitcoin. Bitcoin is a scale invariant system. It behaves in a different way. So this is how a scientist will think about this thing. You see how deep this idea is. It's so revolutionary in comparison with anybody else, So go ahead, ask me your question. Sorry.
If you go back to slide 11, I think, I have some questions, but also my short reflection. I think what I love about this is that I think through different angles, like you can get into Bitcoin, right? And you can start understanding it. And also from these different angles, you can start understanding how big and transformative it is. And what I take away from your presentation now is that what you discovered is actually the confirmation of the fact that that is true, but that this is also a starting point of figuring out why is this happening, and how can, and then I go back to what I said before, how can it be that, well, the only mathematical equation in the original idea is not even relevant for what is happening here? I find that very intriguing, actually. But also the combination of, well, I think it's the title of the theory, right? The energy, the human adoption, the human behavior, hash rate, the price also, right? That all these things work together in a way to show, and that is, I think, my main conclusion, that this low time preference that Safedine talks about is actually something that you can trust upon, because it's mathematically proven that Bitcoin will go up forever. So when you stay stacking Bitcoin, you will also improve your life, right? Like
I love this because
it's backed.
It's one of the because many people are very impatient, right? They would like exponential growth. It is very selfish, because
I think that's what we're learning with Bitcoin, by the way, in general.
We make Bitcoin die. And believe, and if I am right, and it looks like all the data supports that I am right, then you are arguing with Bitcoin. You're not arguing with Giovanni when you're saying the power law is going to be broken. You want Bitcoin to be broken. Bitcoin, in his wisdom, found this path that is the right path, it's the proportional path, it's the long time preference. Bitcoin itself has long time preference. It says,
exactly.
I don't care about your what you want from me. I'm going to do my own thing. I want to grow in this proportional fashion, because that is what is healthy. This is why truth growth in that way, because they use the resources that they have in the most efficient way. This is the most efficient. I have a task. I need to become a monetary system of the world, and I'm going to do it in my own way. This system is intelligent. Some of the things that we like about Bitcoin, we say all the time, it is intelligent, it has wisdom, Bitcoin is the way, all these things. It's true. And so we should listen. We should listen. We should not impose our limited ideas. And instead, we should learn from Bitcoin. Bitcoin is teaching us a very long preference time. And it's not just that. Do you remember the example of the cookies? We have even a video about that. We say it's basically our adult two cookie experiment where the children, this is what Amos talked about, are rewarded with two cookies if they wait. Well, it's in this case, it's cookie to the sixth. So, for example, do you remember when I say you double the time, you get 64? Guess what happened if you triple the time? So if you wait 30 years, it is long, right? But it's not unthinkable for a young person. It's basically you will be retirement age, right? By 30 years from now. Mm-hmm. Guess what? 64 2 times, right? What happened if you go 3 times? You have a feeling? 3 to the 6 is 720. You see how much bigger it is, right?
Yeah.
It's the opposite of what happened with the Kleber's law, where you have an economy of scale. You have an abundance of scale here. If you wait longer, your rewards is going to be bigger and bigger and bigger. So it's not 2 cookie, it's 720 times more cookie, So this is why it's good to wait. More you hold, and bigger is the reward. And the other thing that we always emphasize in my post, etc., and so people sometimes they push back, is if you understand actually we have these cycles and you play the cycles. And here is a little bit controversial because some people will like hodl. We say, why not, right? Why not to use a cycle where maybe you sell a little bit when you're close to the top, or maybe if you are hodl, you don't buy at the top, you buy at the bottom, right? Don't. If you understand how Bitcoin works, use that knowledge to your favor, and that also helps you to multiply your Bitcoin. So if you go deep and you start to understand Bitcoin, you're getting familiar with the idea of the cycles, how they happen, how they are related to the power law in terms of deviation, etc. You can actually, now you go from science to technology, and you're using that technology to help you. And this is one of the things that we do, for example. This is why I have a Discord community. People join the community, we'll help each other. We are trying to ride what we call riding the waves. That is basically trying to understand when it's time to maybe do DCA at the right place. If you want to do DCA, don't do it close to the top. Saves your money. Buy back when we go back to that bottom that we can predict so incredibly precisely. The bottoms, we get it almost perfectly. The tops, almost. We can tell when we are in a region where it's not a good idea to buy because of this deviation from the power law, and so on. And some people want to be a little bit more aggressive. Maybe they sell a portion of their Bitcoin to rebuy back when you go back to the bottom. Do it in a very careful way, very aware way. But you can use this knowledge to your advantage. And this is why we are developing indicators. We have a Discord channel. We are creating a community of people that want to go deeper, both in terms of understanding. This is why we also have a book club where we read together this book, this scale, to understand power laws all around us and the relevance to Bitcoin. But also we want to use the technology. We want to apply the science to understand when to do certain things that can help us multiply our Bitcoin with, carefulness, awareness, not doing degen things. But, it's a very powerful understanding about Bitcoin.
Yeah. And so I wrote down, so a power law basically follows the most optimal way to reach its target object, is what I wrote down.
Correct.
What do you think of that?
This is why you see, for example, them in physiology all the time. A lot of the physiological parameters are ruled by power laws. You know why? Let me explain you this. Power laws, and I have done it mathematically. I had a long post asking people, please follow me. And I had so much of math, and some people follow me. But if you have a little bit of math knowledge like calculus, then it's not really difficult. And you can show that if you have a process where your input becomes the output, and then the output goes back and it becomes the new input. So if you have something like that, it's basically what is called an iterative process. This is how fractals are generated, for example, by doing iterations like that. If you have a process like that, where the output becomes the input, and then the input becomes the output, and so on, like a feedback loop. And look at the graph, right, that you told me to point. It's all about feedback loop. The difficulty adjustment, it's a feedback loop. See, it's actually, Satoshi probably didn't think about power law, I don't know, but for sure he had in mind some kind of iterative process by introducing, it's almost like a thermostat, right? So anytime you have something like that, and physiology, for example, we have a bunch of iterative processes like that, where are, like if you extend too much a muscle, there is one that wants to contract it in the brain. When you're getting too excited, there are feedback loops that want to bring you back to stable. It's called homeostasis in physiology. You want to find equilibrium. If you have something like that, you can show mathematically that the result, it's a power law. In fact, I have a graph somewhere where I did a simulation. I made like an artificial Bitcoin. Hopefully I found it. But basically, in this simulation, I think it's this. Okay, I don't know. So first of all, this graph, look at this graph. This is, the linear power law, how it looks like. Then the, semi-log, this is how it looks like. And so I also have what is called the full model, where I actually try to also do something to cover the bubbles, to actually predict the bubbles. And I add this component, because once you have a general trend, you can add some pieces. I say, okay, now what about the bubble? And I have this model that try to also to predict the bubbles, the bottoms. Look at this; it's almost perfect, right? And this is what you see. The blue is average Bitcoin average over 3 months. When you start to average Bitcoin, it looks almost perfectly like the full model. It's incredible, and this is what it looks like when you do have the power law. It looks like a straight line, right? This the familiar one, the hockey stick, it goes up, right? Do you remember when people say, oh, this thing went parabolic? Parabola, it's x to the square, right? This is x to the cube. Sorry, it's x to the 6. So it's a super parabola. It's very, very fast, right? It's like almost indistinguishable from an exponential, but it has this scaling variant. An exponential is not scaling variant. Scaling variant is this key that makes it grow proportionally. That is so important for Bitcoin, because you see, it needs to grow in a sustainable manner. And these feedback loops are a key, because basically what happens is every time Bitcoin is ready to go up by a factor of 10, you say, wait a second, I'm not going to do it too fast. I'm going to do it proportionally. So if it took me 10 days to go, this is why it was going very fast in the beginning. I mean, it went up, let's say it went up by a factor of 10 within 2 weeks. Well, 2 weeks is about 10 days, right? 14 days. When it went to the next factor of 10, so it went maybe from $1 to $10, now it didn't do it in 10 days. He did it in 100 days, because it needed to go slower. You need to go up by a factor of 10 in price, but it had to take the time to do that in a proportional fashion. The long time preference that we talk about. Now, once it goes from 1,000 to 10,000, again, another factor of 10. Now it's not anymore weeks, it's years. Now, when you go another factor of 10, from 100,000 to 1,000,000, it will not be years, it will be a decade. This is why it's going to take another 10 years to do that. You see, it's Bitcoin deciding, yes, I'm going to grow. And by the way, the beautiful message, it's you are not going to stop this damn train. It's unstoppable. That is the message. Like Bitcoin is not going to zero, and almost for sure, because we can never say sure, even for the planet. And with social phenomena, there is more uncertainty, like we say, right? There is uncertainty with physiology. There is even more uncertainty with social phenomena, but not complete uncertainty. There is still a lot of predictive power that you have through these signs. And you can say with as much certainty you can, the biggest certainty you can, given that is a social phenomena, that we are going to reach $1 million, because given that has done this for 15 years and has done it in this proportional fashion, he will continue to do whatever process is behind, because this is the focus. This is why it's a theory. We are focusing on causes, mechanisms. The mechanisms are going to exist there. Whatever created the social interaction between people that produce this spread of a virus, the fact that the network values itself with the square of the users, is not going to change. It's going to be there. It's going to stay there. And that almost guarantees, that we are going to reach $1 million, more than anything else, more than Saylor moving his hands. I love Saylor, I adore him, but he's a great man. He's almost like a physicist, an engineer. He's basically an applied physicist, and he talks the language of physics. But I don't know if he is aware of this, but this will be like his bread and butter. And I know people say, "Oh, Saylor is against models, etc." I don't know how he could be against this, because this is basically supporting all the things he says about energy, about thermodynamics. It's all there. Maybe he thinks about other models, but this is not a model. It's a theory about Bitcoin, how it works and why it works, scaling variant. He knows all these things. I don't know, I don't know if he's aware, but I would like to actually talk with him about this, and say, what do you think? What is your ideas? But it doesn't matter what Saylor says. It's important what Bitcoin says. Bitcoin says, I am a scaling variant system. I will continue to work in this way for the next 10 years. And by the way, I know it sounds big because it's 10 years, but again, in terms of scale, it's nothing else than being proportional, right? It's just one order of magnitude. Bitcoin did it for 9, for 8. So, it's not going to be any different. It will be crazy and absurd if he did something different. He will not. So it's a really incredible, and it's powerful, and it teaches a lot of things, like the preference time that you told about. So, I was telling you, I don't know if I can find that slide, but I did like a little simulation where I made like an artificial Bitcoin. It's here somewhere, but basically, it would be nice if I could find it. But maybe this one? No, I have it somewhere. But basically, in the simulation, what I did, I have also these slides that is really cool, because this is another thing that people don't realize, that we have actually 5 years of out of sample, what is called out of sample. You make a prediction, and then many people say, well, it's just the past, you back tested, Well, first of all, it's a scaling variant, so it doesn't matter. It's supposed to do the same thing for all these years. But you can extend the triangle, like I say, right? You can extend the triangle. And this is what we did. This is from H.C. Berger that you're going to interview. He applied the same model. When he did this article in 2019, just a little bit after I did mine, inspired by my article. And he kind of expanded it, and he go a little bit deeper, and he made this graph. And the blue line is when he did it in 2019, and then he published a new chart with the new data that is red. And you can see scaling variance. I can use the triangle up to the point, and then I could have made the prediction and say, hey, let me extend it until 2024, 5 years from now. Who is able to make a 5 years prediction of anything that has to do with assets of finance, not even gold or anything?
I love how the line touches the bottom.
Right, and it touches the bottom, and it continues to grow along that center line, etc. So, we have already made a prediction for 5 years to tell you exactly what is happening. So you can extend it, and you can extend it, and you can extend it up to when Bitcoin is a million for sure, because it's only one order of magnitude, it's not a big deal. And then 10 millions is 2 order of magnitude. 10 million is where I start to get a little bit more careful. I have no problem extending this for 1 million. It will be really, really weird. We are going to watch it. We are going to do what scientists do, observe and see, and try to see if it really behaves in this way. But everything we know that is any scientific thinking, there is nothing wrong. I challenge any scientist, to come here. Giovanni is full of shit. He doesn't know what he's talking about. No, actually, the other way around. The scientists that interact, like Fred Krueger, that you interviewed, that is a Stanford math PhD. He worked for Wall Street. This finance professor called Sins. He did calculations of this slope with using half of the data and then everything else, to show how stable this graph is. And this was in an interview with Fred, where Fred was interviewing Saints. He does this as a job, analyzing different financial system, etc. And his precise words were, "I never see anything like this in all my finance career. I investigated hundreds of financial system, stocks, gold, commodity. I never saw anything like this. So consistent, so precise. Never. These are his words. I didn't make them. And Fred, as a physicist friend, a PhD from Harvard, he discovered this after me, but he basically rediscovered it. He came up to the same conclusion, and he's like a power law fanatic, like me. They're like all the scientists that I interacted so far, everybody says, yes, Giovanni, you are into something. And this is why I also want to publish in a journal, that is peer reviewed, and other scientists will validate, through the process. Okay, it's valid. Your arguments are valid. Yeah. It's as best as we can as science to trying to understand Bitcoin. And it turns out that it's a worth subject to be studied as a science, and so, it's different from, like I say, anybody else that did anything like this, because I never saw any approach based on scientific arguments in finding cause and effect. There is nothing else. STF kind of tried to do that, but it didn't, and we can talk about SWF another time if you ever want. But
let's go back to
this is a real science,
Yeah. Let's go back to slide 11. I have a few questions. I'm looking at the time. I love to listen to you. I see your passion, and I think it's really cool. So, but I want to be mindful also of the time, people who are listening. So I have some questions. Sure. I want to ask you to try to be short in the answer, even if that's possible. Or maybe that's a fun exercise. Let's say you publish in a paper.
Yes.
Right. And it gets peer reviewed. And everyone says, yes, Giovanni is correct. Bitcoin will be at 1 million in 2033, 2034. Yeah. What happens if more people start buying Bitcoin, hodl it, right? So then the available supply does go down. The mind virus spreads more and more. More people study, more people understand. Inflation goes through the roof. All these things, right? So there's certain parts in the circle that you show in these in this slide that would get accelerated. How does that impact the power law? Like that's I think this is the main thing that I kind of run into, because it's a virus, right? Let's if we stick with the AIDS example, right? If more people decide to have unprotected sex against what they thought they knew was true, right? The virus will spread as well, right? And I think with Bitcoin, for example, the learning curve is also
it's a great question, and let me answer it in a few ways. So the first thing I will say, right? So is that this is why things happen in a certain way with Bitcoin, because that is exactly a manifestation of human nature. The fact that now more people will know will only reinforce. So one of the reasons why it was a cube instead of being an exponential, the spread of AIDS, is because there was a lot of information given about AIDS. So people started to know about AIDS, so they started to be more careful, not less careful. To say, what if people decide, people don't do things randomly like you think they do. Like, out of the side, let's fight Giovanni and his power law, and let's start to do something that goes against our interests. We are not going to do that.
Okay, maybe the example was bad. I mean, more
no, but I'm serious about this, because the reason why Bitcoin is behaving, so it's the other way around. Basically, Bitcoin is telling us people behaving this way, no matter what. Now, locally, they can do things differently. Like, for example, the bubbles are that think different. Like once in a while, when there is the halving, everybody gets excited, everybody starts to FOMO, and they start to push the price to crazy level. Guess what? Bitcoin says, I had enough, I'm going back home. And it goes back home. You show you that graph where it goes precisely back home. It does it. And you are not going to fight this thing. You're not going to fight.
But that is the result. That is just to illustrate for me further, right? So that's the result of the human behavior, right? But then even you writing the paper is eventually
what do you think? COVID,
a form of human behavior.
COVID is that deep there, right? So COVID was this disastrous, crazy thing. Supplies were disrupted everywhere. People didn't work. We were all this. The price went down like crazy. It found that line and it bounced back. That is like, actually, as a scientist, you will use that as an example, almost like an experiment. Like if you did an experiment, say, hey, let me do something crazy to the system, because it's a passive experiment, right? Like in astronomy, when we cannot perturb a star, there are a lot of things that we can do in the lab, and make a liquid colder, warmer, and see what happens. With stars, you have to wait for the stars to do something, right? You have not a giant stick and you can poke the star, right? You have to wait and look at many stars and see this one is doing this other is doing this. With Bitcoin, you have to wait for crazy events like this. We have a crazy event like that. We had the bands. You can go back and look at all kind of crazy things that happened to the history of Bitcoin. ETFs. The ETFs, there was a lot of FOMO. People started to think all this crazy thing about ETF happening. The price went up like crazy. It left that curve. And look what is happening right now. It's cooling down. It's coming down, because this is what Bitcoin wants to do. You will see, in the next cycles. We are going up. We are going to reach some crazy height. My calculation is about $200,000, $210,000. We are going to reach that. We are going back down. We are going back to that straight line. People will not be affected by me writing the paper. It's not what is going to happen, because Bitcoin, these feedback loops are so powerful, are so consistent. It's almost like a difficulty adjustment, right? Miners come in and say, hey, let's try to mine more. Let's bring more. Or, during the time when there are ordinals and things like that, things go crazy, then fees go too high, and the system adjusted itself. The difficulty adjustment there is almost like a thermostat, right? Every time the system goes away too far, it wants you to bring it back. It's a core element. If we didn't have a difficulty adjustment, probably will not have this effect. It's central. This is why in my slide 11, I put it at the core of why we have this feedback loop. Like, this was an addition. So this Bitcoin standard has only this one. It doesn't have this one. I added. I say, you have to be mindful of that. That is a very important, from an engineering point of view. He's an economist, right? Amos. I think he came up with this. I don't know if somebody else came up with this before him.
I think so too.
But I am a physicist, an engineer. I need this. For me, this is an important element, because in physics we will call it a control system. It's a feedback loop. It's a very fundamental part, and some of the reasons why we see this power loss, because this is exactly when you get power loss, when you have something like this, when you have a feedback loop, you can show it exactly mathematically. This is how it happens, and so me making the paper, me spreading the news. By the way, so many people are resisting it anyway. They don't want to believe it. They don't want to accept it. It's still a minority anyway, right? Same thing with Bitcoin. Like, Bitcoin should be this thing that you say, how come not everybody is accepting Bitcoin? It's going up so much. I mean, I talk with some people and we say, because I try to orange peel all the time, and I'm successful. I'm becoming successful with that. But there are still some people that say, oh, yeah, it was not a thing a few years ago. Was not Bitcoin a thing a few years ago. I remember it went up, $5,000, $20,000. I remember 20,000. And then it crashed, to nothing. And it disappeared. What do you mean it disappeared? You know that is $70,000.
Yeah, it disappeared for you.
Disappeared for you because you didn't pay attention or didn't want to learn. People are still ignorant. And by the way, if this thing is right, with adoption, which goes with the cube, That means that in 15 years from now, we only go 8 times, because 2 to the 3 is only 8. The price is 64 because it's a square of that, but adoption is only 8. So if we are 100 million of us right now, it's going to be only 800 million in 15 years from now. It's a very slow process, methodic, consistent, but it's much slower than people think, because there is thinking and there is awareness. It's something that it doesn't happen overnight. And so
I think this is I think this is the kind of the why part. I think my mind is kind of stuck in the why part.
Right. Yeah, you're right.
I'm a bit of a rational thinker. Like
Of
I
course.
agree what you say. Like I'm like, why doesn't everyone understand this? But I know how early we
it's
still
the same
are.
thing with Bitcoin. Why not everybody jumps in Bitcoin, right? For us, it's obvious. Like how it's possible after I tell you about Bitcoin, I tell you it's going up and it's recovering every time. You can tell anything you want. If a person is not ready, ready. They are going to dismiss everything you say. Same thing here. If people are not ready to understand these things, they are going to dismiss it. And also, if I understand what they are going to do, are going to play against Bitcoin. Bitcoin doesn't care, he doesn't care. Like, sure, you can, even Sailor, when he say, oh, few of us can come, few millionaires, and what will happen? Yeah, you will spike the price, like it happened with the ETFs, but then the price will go back to where it wants to be. You cannot game the system. Bitcoin is again gaming the system. Same thing with the miners. The miners cannot game the system because of a difficulty adjustment. Same thing. This difficulty adjustment is a key component of all these, and it brings down. It's almost like a thermostat. Is why it follows this process, because the mining component is a fundamental component of this system. It will not be. This is why it's not like a gold. Gold doesn't have a difficulty adjustment process. It's not like NASDAQ. Nothing has this very important component. By adding it, Satoshi, I don't know if he thought about that, he created like a control system. Now, the other one is the halving. And we have an entire video about the role of the halving. It has nothing to do with a supply shock. It has to do with the Moore's law. And again, I don't know if Satoshi thought about that and introduce it, but the fact is the same. Basically, the Moore's law, it's like one of these exponential. In fact, it's the only exponential that doesn't die. And the reason why it doesn't die is because there is innovation. Every time it's the technological progress is ready to die because it has reached its limit, like when people use vacuum tubes, right, to do computers. Computers were based on vacuum tube. They invented the transistor. So the transistor represented a phase shift, and you push it that exponential up. So if you look it up, it's almost like it looks like continuous. It's actually a bunch of little hockey sticks. When the one hockey stick is almost ready to die, there is another hockey stick that takes place, right? When the transistors were too dense on a chip, they decided, okay, let's do parallel processing. They introduce all these cores. Now maybe they're going to do 3D cubes, that they are coming with quantum computing. So the Moore's law has been continuing to go up. It's exponential. It basically goes like this. The miners will have an advantage of about 4 every 4 years. And because of this relationship between price and hash rate, the system somehow adjusted itself where it's reducing by a factor, the square root. So basically, the miners will get an advantage of 2 every 4 years because of the square root instead of 4. But then there is the halving that reduces that factor of 2 to 0. So basically, the halving has the role of bringing everything to equilibrium, where the miners neither get an advantage, neither get punished. Because this is what I thought all the time. Why Satoshi hates miners so much, where he punishes them by a factor of 2 every 4 years? No, it's all about keeping the game fair. Because otherwise, because of a Moore's law, they will get an advantage, and that will create some disruption in the system. But because of the halving and this It's probably this thing came about, this 1/2 came about to actually make the system balance. It's one of these things that self-adjusted itself, where in the end you have this relationship between hash rate and price, where everything mathematically plays perfectly, where basically there is not an advantage to the miners due to the Morse law. Everything stays in equilibrium. They have a little arbitrage where they can make some money, but they don't make more money as time passes by. And it's fantastic. It's again another thing that brings equilibrium, it brings balance, it brings exactly what is needed at every particular point. And so you see, every time somebody's trying to game the system, Bitcoin says, no, I'm not going to get gamed. I'm going to do my own thing. I have all these multiple feedback loops that regulate the system. So if you are sailors, they say, comes up with a bunch of friends, they want to buy Bitcoin and do something crazy. First of all, why doesn't happen? Why doesn't happen? Why that doesn't happen, right? Why there is one sailor and not 20? Because tell me what Sailors was doing 6 years ago. He was
okay, but then you say they will come in due time.
Sailor was shitting on Bitcoin 6 years ago. He was saying bad things about Bitcoin. Why? Because Bitcoin was not ready for Sailor, and Sailor was not ready for Bitcoin. When it was the right time, Sailor came about.
Exactly, yeah.
And so he changed his mind. He's a clever guy. He's one of a clever billionaire, and there are not many clever other billionaires like him. Look at what happened with Bill Gates. He hates Bitcoin. Look what happened with Elon Musk. He bought some Bitcoin, he sold it. He likes Doge. Can you imagine? He likes Doge. Elon Musk, right? So this is what happens. Everything proportional. This is the nature of. This is the human nature. This is the human nature. The clever people like us have already joined, and there'll be other clever people that need more time, and they will join when the time comes in. So bottom line, this shows us that you're not going to game this system. This is Bitcoin. Bitcoin is the way. You don't go against the way. It doesn't matter. Even being aware of the way, it helps you to learn about Bitcoin, or maybe even use some of these ideas about the cycle to your own advantage, so you multiply your Bitcoin if you know what you're doing. But you cannot game the system. You cannot try to push it in a certain direction, maybe momentarily, and you create a spike, and then Bitcoin wants to go back there. This is the bottom line. This is my hypothesis. This is when you do a theory, one of the most fundamental thing about theory, the theory needs to make a prediction. In fact, a series of predictions. It's almost like a way of staying honest, because if a theory didn't make any prediction, it was just a fantasy, then there is no way of checking what you're doing. So many people are telling me how the theory can be invalidated. It's something that I want to work on. I want to give a series of parameters, say if this happens when the theory, there is something wrong with the theory. I need to work on that, and it's a very high priority, because it's important to be honest when you do science. But one of the things I will say is this graph that I show you so many times, is this bottom line graph, right? Where if something is violated there, where you see a huge big dip, and we go down much more than we should go, and we don't come back, or we stay too long below that graph, that is where the theory gets pushed, because these tops are FOMO, and really we are trying to include them in what we call the full model, but they are not really as important. They are like basically distortions or deviations from the general trend. This is really where the test of a theory is. If by the next cycle, for example, right, let's say we go to 210, and right now I'm trying to make an estimate of a top, but that is not part of the theory. That is an addition. Let's say it goes 300,000. That theory would not be invalidated, because the theory says, it's probably unlikely, but not impossible. But then if it goes down, and we are predicting 70,000, if it goes to 20,000, yes, the theory will be invalidated in that case. So we are saying, in fact, the bottom is around 70,000, and this is where we are going to wait. And I'm going to be very, very eager, not nervous, because if it is broken, then something is happening with Bitcoin. It is also what is useful about the theory, because it will tell us, hey, something is different from before. Bitcoin has done this thing for 15 years, now it's doing it something else. There is some mechanism, some cause that is behind this, because for sure there is a cause here. This is not by chance. It's not me drawing some arbitrary line. There is something going on there that I try to explain, and maybe it needs to be explored even more. But it's all about understanding Bitcoin. So if there is a deviation, like the elephant tooth, right? If the elephant start to do something different that it's supposed to do in the growth of his task, then maybe the elephant is sick. Maybe doesn't have enough nutrition. Maybe something is going on, and so that allows us to actually understand Bitcoin, even when things don't go like the theory says it should go. But my bet is, my very strong bet, my scientific bet, is that he will not violate. He will go there. There is a reason why this happened. He will continue to exist. And that is where we test the theory, where it breaks or it makes the theory. And like I say, we already did it for 5 years. It's now that it's a new theory and we need to test it from nothing. We have already 5 years, but we want to continue to test, until Bitcoin. So this thing is not going to be valid anymore when some big nation of entire world decides not to use the dollars anymore, right? So we go to Bitcoin standard, we just use Bitcoin. Then Bitcoin task is over. So this story about this, it's all about how Bitcoin is growing, right? Once it becomes an adult and is adopted by the entire world, then the story is over, right? It's another story. Another story will happen. I'm sure that Bitcoin will continue to do amazing scientific things, but it will be a different story, right? So this is a story of how Bitcoin went from being nothing and being just Satoshi and a couple of friends, all the way to be the monetary system of the world. When that happens, if it is 10 years, 20 years, I don't know. But I know that it will continue to do it in a very precise, scale invariant way, because this is what Bitcoin is. It's a scale invariant system.
Yeah. I will try to wrap 2 questions into one, and then I will ask you my last question, and then I'm off to bed, I think. I love it. I'm my mind is rattling, but I'll try to put 2 questions into one. So, and perhaps I'm still on the why path, so excuse me for that. So,
no problem.
If so, I see price kind of as a proxy for adoption, right? And if Bitcoin is the black hole of value, it will take all the monetary premium that is there in the world, which is allocated in the wrong place. It will put it in a place where the wealth is preserved, right? That's the concept. Does it matter that the value that it's sucking up was already there before? I don't know why I wrote down this question before.
It's a transfer, right? It's like transferring.
It's a transfer. Yes, correct.
It's
but
like
wait,
you have to. Go ahead, finish.
Let me finish the question. So, if we have this big bubble, right, of all this monetary premium, where all this value is already allocated, and we're moving it towards Bitcoin, as you said, it's a transfer. How can we then see these diminishing returns in the future? Because there will be, again, I talk about the scarcity in a sense that if more people hodl and there's less Bitcoin available, if the big amount of this monetary premium moves in these little amount of Bitcoins that is available for sale, the price has to go up, right? I mean, like, this is more my rational thought, but can you combat that?
Yes. First of all, why? So I think we should abandon the diminishing return, because it's a very negative way of thinking. It's more about waiting longer for a bigger reward. It's about the preference time. And remember,
Good
Bitcoin
point.
simply says, listen, I need to go up a factor of 10. I cannot do it in an exponential way. Otherwise, I suffocate myself. I will collapse. So I need to do it in a way that is sustainable. The only way is to take longer time. So if I go up by a factor of 10 in price, I will take my time. I will take a factor of 10 in time. And this is what has done for 15 years and over 8 orders of magnitude. And it has worked. This is why Bitcoin has survived crises, has survived bans, has survived everything. That is the way of Bitcoin. It's a very resilient, powerful system. And the trade-off, that is going to take its time. So that is the answer to that part of the question. The other is, what you are envisioning is not what happens, because, in fact, let me find the graph, it shows you exactly what happened because I have a graph. Okay, it's this graph. This graph shows what happened to all-time holders when price goes to a certain level. So it's a myth that there are these people that hodl, and never sell. I don't know who is spreading that myth, but I'm a little bit upset about it. That is one of the things that some people criticize me, like I'm against the community. I'm not. I love the community, but I want the truth. Okay, we need to understand the truth because Bitcoin is all about truth. Don't trust, verify. Don't trust anybody that says things. Try to understand Bitcoin. What this graph is saying. First of all, the yellow line, that is what I was telling you before. That are the rewards for the miners. See how, as we are approaching the halving, the rewards for the miners go up. And then there is a reset. There is a reset. And where they go back
they
to
do exactly the same. Yeah, it's interesting.
Right, that is what I was telling you before, that how Bitcoin works. And the blue line is the long-term holders. We get more long-term holders as the price goes up because of FOMO. So more people, that is when actually price drives adoption. That is the other way around. During these FOMO times, people see the price going up and there are more people coming in and they became long-term holders. But then what happened? When we reach the top, they drop. They long-term holders, the one that were there before, they start to sell. And that is healthy. That is healthy because we want Bitcoin to be liquid. Imagine a world where everybody was holding and never selling. How do we get adoption in that case? That is against the idea of adoption. There will be no people being able to buy Bitcoin, so there will be no new Bitcoiners. And we know how the price goes up with Bitcoiners. We already showed the graph is that, right? Bitcoiner square. It goes with Bitcoiner square. We need more Bitcoiners. If people hodl, there will be no new Bitcoiners. How can you get
money? It's the natural. It would be the natural distribution of those coins, then,
so
right? Because
there
of
are cycles,
the level of understanding.
Right, where there is distribution, there is redistribution from people that hodl. They want to get some rewards, because maybe they hodl enough. Some people hodl for 4 years. Long-term holders here means at least 4 years. And you can actually, I don't have it here, but the people that hodl for short amount of time, they do the opposite. They buy at the bottom and they sell at the top because they don't know what they are doing. They are all long-term holders. They know what they are doing. They are selling at the top and then they are rebuying at the bottom. It's not that they are leaving the system. They're taking this energy, this propulsive energy of Bitcoin that goes up. They take advantage of that and they multiply their Bitcoin because they sell it at the top and they rebuy at the bottom. This is what it shows. They're going back to Bitcoin once Bitcoin goes back to that bottom. And they kind of know, maybe from an entity point of view, maybe because they look at the chart, it's an average thing. Some Bitcoin are better than others, but in general, it's about 60% of the long-term holders that do this. And so the scenario that you are describing is not going to happen because it doesn't happen. When Bitcoin becomes scarcer, is when these guys are dropping over, they are getting cash instead of Bitcoin. And it's healthy because in this way you have a redistribution, you have new holders, you have a new Bitcoiners, and it's good. It's good for the system because we want Bitcoin to be liquid. It will not be good store of value and even less a monetary system if it was not liquid. Because imagine the Colosseum. The Colosseum is unvaluable. It's one of the most valuable things in the world. It's a unique piece of architecture, and that's an enormous value. But can you sell it? No, and so it's not liquid. It's almost like if it was not valuable at all. Yeah, you can have tourists, you can get some economy, but nobody's coming to your home to watch your coins and you charge them a ticket, for that. It's no good if it was no liquid. It's important to be liquid. So this fantasy that we are running out of Bitcoin is one of the things that drives me, almost crazy. And I see some very influential, I will not name anybody, but there are some influential Bitcoiners that have this fantasy and it's not based on data. So that is one of the things where I have a little bit of friction. Hopefully
maybe to defend that a bit. I don't think it's fantasy because I just said it. I don't think for me it's not a fantasy. I think it's more comes from a rational way of thinking, right? Like if I understand
Okay, so
Bitcoin, then
let's call it an
wait,
hypothesis. Yeah, yeah, go ahead.
why would I sell it for dollars, right? And if you think about if it's like a virus, the mind virus, and more people slowly, right? It's slow, so
Yeah.
they start to understand it. The less people will sell. And I think if I look at your graph, the peak of each, it's higher. So there are more long-term hodlers over time,
Yes.
but it's going very slow.
But also there are these cycles, right? You can see that the effect of the bubbles is to actually for the hodler to sell, and then there are new Bitcoiners and so on. So it's not really scarcity; it's adoption. What you're seeing there is adoption. So you're right. The virus is spreading with the cube, but because it's relatively slow, because cube is fast, but it's not an exponential, is going to take its time. I told you 15 years is going to be only 8 times more Bitcoiners, right? So this idea that we are running out of Bitcoin is not what is driving the price. It's more like this adoption that is a form of demand, but not quite. It's more like...
You said 15 years and there's 8 times more Bitcoiners?
Yes. And so it's a slow process, but a very methodic, very precise, very mathematical process. And so we are not running out of Bitcoin. And then it's very important that we are not running out of Bitcoin, because that will be a bad thing for Bitcoin. It will not be a good thing for Bitcoin. So it's good that we have this balance between people hodling and keeping their Bitcoin and investing in Bitcoin, but also that there is some liquidity, right? That allows other people to come in. So otherwise it will not work, right? So it works perfectly. Everything balances itself. The bubbles have an important function because people like also these impulsive things. We like this cycle, we like Christmas. It's almost like Christmas, right? It's Bitcoin Christmas. These bubbles are Bitcoin Christmas. There is a lot of FOMO. There is a lot of excitement. It brings innovation. People like this kind of periodic kind of things happening at certain times, right? And it's part of how Bitcoin works. It's basically two phenomena: the long-term growth that is the power law, and then these bubbles and this impulsive behavior. But the two combine together to get this overall growth that like I saw when I show you this graph, that do you remember that graph that I showed you before? What they call the bottom line, behavior that we already saw many times. It's like there is the bubble, the price goes back and goes back to the trend. It's almost like the bubble didn't exist. That is the overall effect. And so, anytime I look for anything that has to do with scarcity, like having less Bitcoin or supply shock, I show to myself and hopefully to others, because I wrote articles. Eventually, I want to put everything in a book, so people can read, look at all the evidence, references, everything. But I challenge anybody, any analyst, anybody, show me, because I want to know. I want to be proven wrong, not because pride or anything, because I want to learn about Bitcoin. Anything that has to do with scarcity, like people are using circulating supply, all these other measures, nothing like that correlates with price. The model that I have only needs two things. It needs Bitcoiners growth that goes up with the cube, and it needs Metcalfe law. And now actually you can also use hash rate, but hash rate I think is the other way around. It's a price that drives hash rate. But you can combine it and make a model where you have hash rate, you have addresses, and then it's all what you need. There is no place for supply. There is no place. In fact, I have graphs, that shows here, this graph. This graph shows this is issuance, right? So look at this. Issuance, if you look at these blobs, each single blob is not related to price. This is why it's flat. It means it's not correlated with price at all, right? So during the halving, there is no correlation at all. How is possible? Well, because the issuance doesn't matter. And why is different? Why the issuance sometimes bigger, sometimes smaller? Because of the block time, right? So if there is more hash rate, you produce more Bitcoins, then the hash rates wants to bring you back. And if there is a correction, but in the meanwhile, you are going to change the production, right? And there is no, this every blob here represents the time in between the halving. And you have more production here on the left, the issuance of coins. On the right, this was early history, and this is as you go to the left, you go to recent time, because you see every 4 years there is a reduction of 2, right, in terms of issuance. So the number of coins produced in general becomes 2 times smaller, right? And now this halving creates the illusion that there is some kind of correlation with price, but it's only because this halving gives a direction in time. It's like simply saying, as time passes by, there is a reduction in general of the issuance. But it's almost like saying my age goes up, right? And that is also correlated with the price. So me changing and becoming older makes the price of Bitcoin go up. It's an illusion. It's completely an illusion, because I could eliminate this jump happens only on one single block. How that can affect anything? Nothing. It's just an illusion. And so, in general, if I eliminate that jump, then you will see just a blob. It's just a blob. There is no relationship between issuance. You cannot make a model that means anything. S2F tried, and this is why it's garbage. In fact, I can, and sorry if I talk about S2F, but right now it's important, it's the right place. I can substitute this issuance with random numbers. I can take random numbers that don't have anything to do with Bitcoin, and I produce exactly the same model than S2F. I have a slide here. See? The blue line, it's the real S2F. The red line, it's my random noise model, where I substitute issuance with just made up numbers. I can make up with this number. In fact, you know what? I could have issuance, I can have halving every year. It will look more steps, but it will reproduce exactly the same behavior. Simply because by doing this jump, I create some kind of directionality in time, right? I'm just saying there is a general trend for going up S2F, because you are dividing by issuance. So if you're reducing issuance, even an artificial issuance, even just a made up issuance, I use soccer stats, because every 4 years, the price of soccer players, the World Cup players, goes up, right? I took that numbers, I substituted here, and I have a model based on the prices that are given to the World Cup. They reproduce perfectly the price, simply because they go up in time, and so they correlate with price. It's nothing, So there is no. This is why you get these flat lines. Nobody ever asks, why do I get flat lines in S2F? Because issuance doesn't have any relationship with price. The only time when it looks like there is something happening is that halving, because it's completely artificial. It's artificial. I can have a jump due to the soccer price being bigger, and it will still correlate with Bitcoin. Tell me, right? I made the analogy, I say, is the same thing of these machines. The Theranos scandal. They had machines where you put some samples of blood, and it told you, oh, you have this illness. When they tried something else, and it still told you have this illness. It's like I have this machine, I put oil, and it tells me you have cancer. I put Coca-Cola, you have cancer. I put, it gives me the same answer. Yeah. If it gives me the same answer, it doesn't matter what I put in. It means there is something wrong with the machine, right? It doesn't work. And so the same thing with S2F. This is to make a point that issuance has no role in the behavior of the price, because it doesn't care. Bitcoin doesn't care about that. This to answer your question. Those hodling, etc. It doesn't happen, because I just showed it. As the price, same thing with the ETF. People think, oh, the ETF will never sell. It's not true. In fact, they will sell even faster than the normal hodlers. Now that we're putting so much money in the ETF, these are managers, right? Are managers of pension funds, etc. If Bitcoin goes to $500,000, you don't think they are going to sell? They are going to sell very fast. By the time these people are used, to 10% a year gains, if they start to see 20, 30, 50% gains, they are the first one to sell. It's almost actually
yeah, they're probably scared. I agree.
we need to be actually be careful about that, right? Because it's possible that they actually are a negative influence. But I don't think so. If we are going just to make the market more liquid, etc., the same mechanisms are still going there, because hodling doesn't really matter. It's this spread of information, and it happens. Some people maybe will leave, some people will join. It will be a continual process with, it's also the interactions. It doesn't matter. This is why addresses are a good proxy. It doesn't matter if you have, like I showed before, if you have a one big address that does a lot of transaction, it behaves almost like a lot of Bitcoiners. The system doesn't make a difference. It doesn't matter if you have a one big address that does a lot of activity, big, large movements. It's almost like a lot of small little hodlers. So it's okay. It's going to continue to be. In fact, it's a good thing that the issuance doesn't matter, because we are already over with issuance anyway. It's almost like we have all the Bitcoins that we will ever have in the world, So if the price went up because there is a decrease in issuance, is so small and so infinitesimal that it's not going to impact the market at all. Thank God it doesn't work in that way. There are other things like, adoption, etc. So it's much better, more beautiful, more consistent, more philosophical, more rewarding picture. The only negative things, the only place where people could resist it is this idea, maybe two. One, they are attached to the idea that people are free and can do anything they want, and so they want a crazy Bitcoin that can do anything. I don't like that Bitcoin, and Bitcoin doesn't like it. So I like what Bitcoin likes. And second is the idea that we are not going to be millionaire overnight, right? That is going to take time, and we have to learn to be patient, etc. But again, that is what Bitcoin teaches us, and I want to learn from Bitcoin. I don't want to impose my own idea on Bitcoin. I want to learn what Bitcoin is teaching us. It's this almost like a Zen master, right? That is giving us lessons of patience and understanding nature and energy and all these things, all the things that we associate with Bitcoin from an intuitive point of view, the math supports that.
Yeah, well, I couldn't agree more with that. And I think that's a great ending. I'm looking at the clock. It's 2 hours and 55 minutes.
Sorry.
No
Thank
problem.
you so much for being patient. A long time preference.
Yeah. Well, I don't think I said that much, but I think, I wanted to talk with you for a long time, and I think you did a great explanation. I love your passion. I love that you're working on this, and I think, I love that you're just open to the discussion and you go out there on X, and once the paper is done, I hope you get other people to review it, and then we'll see where it's at. And I think you would also agree, let's hope that it gets broken in a positive way, right? If at one point
if
a huge country understands what it is, then
so that is what a scientist does. If they think that you're studying and you're trying to understand does something different, then actually it's interesting, right? When you want to understand it, I hope it's something in the positive direction, not just in price, but also from a health point of view. Because if you are seeing all this activity in a human body and say, oh, that is great because there is all this human activity, and then it's cancer and the person dies, it's not good, right? Because this is what cancer is. It's an exponential process. But if it is something healthy, where the person gets all this good food and it has this, like my son was like me, I'm Italian, he was relatively short, and then because maybe of his Estonian, he's from Estonia, his mom is Estonian, maybe some Estonian DNA that kick in, and he is now taller than me, it's great. I'm happy for him because tall is good. But, it was a healthy thing for him to do that. But, if Bitcoin does something that is different from what he did before, then we will have to go and study, understand why it happened, and hopefully it's a healthy thing. And I don't have any problem because this is what scientists do. You accept reality. You don't impose your own vision and your own understanding on what you're studying. You want to learn. So anything Bitcoin wants to teach me, I'm open, absolutely.
Yeah, awesome to hear. Well, thanks so much for your time
My
and your
pleasure.
explanation. I will make sure to link to, your YouTube and the Reddit posts and your Twitter so people can, check this out for themselves and hopefully learn a lot. And yeah, man, we stay in touch. This is not over
My
yet,
pleasure.
right?
Thank you so much. Thank you.
Cheers.
Bye.
I hope you enjoyed this episode. If you did, it would be amazing if you could rate, review, and subscribe on the podcast platform of your choice. It will help us educate more millennials on the importance of Bitcoin. You can follow and connect with me on Twitter. I'm Bramk, that's at BRAMK. And if you are or know someone who has an interesting perspective on Bitcoin that's worth sharing, hit me up. I read and reply to every single message. I appreciate your support and hope you'll be here for the next episode. Thanks for listening.